Hi, it's stream 278, and today I'm going to be working on measuring the performance of Lua scripts. This is an idea I had a couple days ago that I am going to use probably next week to address the performance issues I have in my game right now that I have added a lot of pathfinding stuff. And the idea is to measure what scripts take the longest to run and to find performance bottlenecks. The programming language is Lua, and the Lua scripts and its interpreter are being hosted in the back end of my game server. So this is what the game looks like in the test environment. So the game server in C++ is hosting the Lua interpreter, and it's running Lua in order to decide what these characters in the game are doing. They're computer-controlled characters, so these green guys are slimes, and they basically are just wandering around. If any players get too close, they'll attack them. George here is an NPC who has a couple things going for him. Right now, when he gets close up to the slimes, he goes over in there and attacks them. And when he's not attacking slimes, he will patrol around this area here. And if a player talks to him and asks him to, he'll guide the player around in the dungeon. Hey there, Rally Monkey. Hey, you're first today. You're the very first to say hello. You're also got the first founder badge. How appropriate. So yeah, an increasing amount of the game that I'm building on top of this custom engine is written in Lua, and it's becoming a performance issue the way I'm doing certain things right now. And rather than just guessing what's making things slow, I felt that I needed to have some kind of tool to measure performance. So for C and C++, I use the built-in performance analysis tools in Visual Studio. But for Lua, I don't have anything like that. I could use those same tools with the Lua scripts, but it won't give me insight onto what Lua scripts are being run because the performance measurements tools look for C and C++ functions. They don't know anything about what a Lua script is. So the idea is I want to make something standalone that you could include with anything that has Lua. And it would add in some extra functions that you can call from Lua to measure and report performance. So the idea is, let's say you had a function called foo, and it did something. You would enable the instrumentation of performance metrics, and what it would do is the equivalent of this rough Lua pseudocode, or Lua-like pseudocode. It would take the function foo and perhaps a name that is foo, or it could be something else, whatever you want to call it in the report, and pass it through this instrument function, and that will basically wrap the function foo, or whatever function it's given, and return this wrapper. And what the wrapper does is it starts timing foo, calls foo, and then stops the timing of foo. And the idea would be, and rather than having to call this for every function, we would also just enumerate all global variables and find the ones that are functions and just do that automatically whenever we enable instrumentation. Disabling instrumentation would be just unwrapping this, so I need to think of a way to pull the function back out and then set it back as foo again. Once I get all that working, I kind of want to make a nice Python tool that captures and reports the metrics from my game. So I think what I'm going to do first is aim to make this a reusable component that others could use. And I'm not even going to search on Google. I'll leave that to others to see if anyone else has done this. I think it'd be really useful. I can't imagine that there is no solution out there. I like to make my own stuff from scratch. So even if there is already something out there that can do this, I'm just going to go and do it right now. With that said, let's get started. I think we'll make just a blank slate here. Still within my workspace, but it's going to be a whole new component. So this will be one of those rare moments where you see how something that I make is made from scratch. So we'll start anywhere here. I just clicked on a random file. That's not a leak. It's a test key. And I'm going to hit new file. Actually, no, I want to hit new directory. What are we going to call the thing? That's the hard part. Instrument is another name for like, or is a category of things, right? Instrument would be like a flute or a guitar or something like that. And then Lua is Portuguese for moon. So is there like a play on words that I can do here between moon and instrument? Or maybe not instrumentation, maybe more like measuring performance or speed. How about we call it speedy? Speedy moon? Or measuring speed, like clocking, like Lua clock or something? I have something called moon unit. What if I have something called moon clock? Names are my kryptonite. That is true. I'm going to call it moon clock for lack of a better word right now. And it's going to be a C++ library that we can bundle in with Lua. So let me take another C++ libraries. README? No, not README. Because this one's for a standalone program. I need one for a library. How about JSON README? Yeah, let's take that. Actually, well, let me check something. Does this have a nice... Oh, it does have a nice prerequisite section. Does it say anything in the building section? Okay, that'll work. We'll take that, the license, and the CMake. Do we want to do this with test-driven development? I suppose I do. It's like, yeah, do I have to use test-driven development? Do I have to, Dad? Yes, you have to use test-driven development. Okay, so we'll call this moon clock. This is a library. It doesn't do this at all. This is a library which provides, what would we say, plugins for an environment, or should I say any environment? Environment including, I wish there was like an auto fix misspelling. A Lua interpreter. Wrap. Oh, it looks like I forgot to wrap these, by the way. That should be wrapped. That should be wrapped. This is a library which provides plugins for an environment including a Lua interpreter and can be used to instrument existing Lua scripts. Actually, any kind of functions, right? Let's say instrument functions available through Lua. To measure their performance. Let me read this again. This is a library which provides plugins for an environment including a Lua interpreter and can be used to instrument functions available through Lua to measure their performance. Sounds good to me. Let's see. Do I need a class? I don't know yet. Let's leave the usage blank. I'll go ahead. Let's see. How do I want to wrap that? Like that, maybe? I will not need base 64. Let's pick the moon unit readme just to select from the dependencies list here, or prerequisites. I'm going to pick out Lua library. Just because that's my fork of Lua that includes CMake. Hey there, Nui. Did you say hello before? Maybe you said hello right at 10. And I like started my window when like 10:01 or something. But hello. Maybe you were first even before I was here. That would mean I was second, technically, and then Rally Monkey was third. Sorry, Rally Monkey. I forgot to start my view timer. Alright, anyway. Well, I need system abstractions. Maybe. I totally edited the wrong thing, didn't I? I was in the... Oh, no, I'm in the correct place. This one I don't need anymore. Okay. Need CMake. Need a C++ toolchain. Need Lua library. Might need that. Actually, I think I'm going to list that we do need it because we're going... Well, at least indirectly depend on it. I think I'm going to end up using my timekeeping class. For clock? No, we don't need that. I think I can use the class I have directly in system abstractions time, right? Yeah, we can use this one. Okay. Yeah, the high performance counter one. Okay, good. We'll use that one. Don't need UTF-8. Okay. How do I mark something to do here? Or what's the favorite three-letter acronym that you'd see in Qualcomm documents? TBD. You know what TBD stands for? To be delegated to someone else and never done. You said hello at 2 minutes after? Okay, maybe I started my client at 3 minutes after then. Yeah. So I missed it. So I think one issue is that like in my Discord, I announced that I'd be late, but I announced it in a channel that's not reflected by that bot that we use in Discord. There's a stream plan channel, and that's not reflected into Matrix, just like the other two are. I wonder if I should bring the bot into the stream plan channel for Matrix, then you'd be able to know that I'm late or not. Thought of determined. I don't know what that's connected to. Oh, determined, yeah. But I was making fun of Qualcomm there. To be delegated, as in, let someone else deal with it. Not gonna be me. Just poking fun at my previous employer. Okay. I shouldn't do that though. I should be nice to them. Yes, it does mean to be determined. Moon clock. It's 2019. Do I have a copyright in here? I don't have a copyright there. This one has a copyright. All right. What are we gonna have? I think for now we'll just have one file. If I need more than one file, I'll make them later. So we need Lua library. Don't need base64 or UTF-8. We're gonna have a test directory. Let's rename this moon clock tests. Get rid of value tests. Moon clock tests. This contains the unit tests of the moon. Oops. Actually, yeah. Moon clock class. Right. Get rid of all the other requirements here, and then now it's completely clean. What to name the first thing? I think I want to first play around with enumerating a Lua environment to find all the functions. So let's build up a function which just does that. So enumerate Lua functions. All right. And then we'll have to make a Lua interpreter for every one of these tests. So let's make a fixture. Let me go find some other test I made that has a fixture in it. Hey there, Romania Hate. It's going well. I'm just getting started today. Started 15 minutes late. And I'm making a new thing, which is a reusable component that you'll be able to use to measure the performance of Lua scripts. And it's going to include features like automatically finding all functions that you have in your Lua environment and giving you a way to like instrument them. And you just call something called enable instrumentation and it'll do all this stuff for you. And then at the end, you can say generate report, and it just gives you a nice report saying what functions were called, how many times, and how long it took. And I also like kind of a breakdown of, for every Lua function, what other functions called it, and what functions did it call, and a breakdown like percentage-wise or maybe time-wise between them, so we can kind of like what I'm used to seeing in Visual Studio, so we can figure out where the bottlenecks are in Lua and, you know, address the biggest offenders first. Yeah, profiling tools. I'm just doing measurements, so it's not going to be like optimization or anything. It's really just to give me more data and more insight about what's going on. Right, so the first thing I'm going to make is a function called enumerate Lua functions, just to play around with this, because I want to automate it as much as possible. I want to have Moonclock be able to just find all the functions for me, and then just go through them all and instrument them all, and then when I'm done, remove the instrumentation. So this would be the first step, I guess. Oh, I wanted to put this into a fixture, right? Need to find something that has a fixture. Something like Raft probably has a fixture. This is definitely going to be a fixture. Yes. Yeah. So this is the fixture with Google Test is a class that implements that is subclassing Google's testing test. In unique, interesting name, don't you think? Testing test. Whatever. So testing test has two base class methods called setup and teardown, which I'm going to leverage in constructing a Lua environment and tearing it down when we're done. Hey there, Toulouse. Testing test. Makes sense, yeah. Very imaginative. You think that the Google test people would find a more creative name for their namespace or their fixture base class, but nope. Okay. So that means it's in a fixture. That needs to be the name of the class. This is a common fixture, or the common fixture for all tests in this module. Should I say more than that? Let's say it sets up a Lua interpreter, Lua environment, let's say, in which to perform some tests. Actually, it sets up a Lua environment and other useful tools which all the tests use. Useful use. Other useful tools for the tests. There we go. I like it now. Sometimes I can be very picky. Moonclock. Moonclock HPP. We'll get rid of this one. Pragma once is the new way to do this header guard thing. We don't need the end if at the end. This is Moonclock. This declares the Moonclock class. It's 2019. We probably only need memory. We can get rid of a lot of this junk down to here. We're going to have a class called Moonclock. Yeah, I'm just trying to think ahead. Does it need to be a class, and what will the class actually do? We'll say this class represents a suite of tools used to measure. How come I can't spell? I think when I can't spell more often, it's because I'm not sitting right. I'm like leaning slightly to one side. Actually, I think it's that the keyboard is slightly off center. Huh. Gotta check the ergonomics. Better ergonomic? Yeah. Represents a suite of tools used to measure the performance of Lua scripts, Lua functions. Keep saying scripts, but script sounds like a second class function thing. You know, it's like, oh, that's not a programming language, it's a scripting language. We don't do scripting languages, we're real programmers. Okay, stripping out that. We'll reuse the life cycle management stuff. And I can just leave that, right? And then I don't even think I need to mess with a constructor yet. But maybe. We'll just remove it for now. Just remove all the methods. I want the private properties to use the pimple pattern. I'm going to guess unique pointer is fine for that. And go with that as a nice shell to begin with. Here, moon clock CPP. Contains the implementation of said thing. It's now 2019. Time flies. Alright, don't know what else we need yet. Probably need Lua, though. Probably. Yeah. Let's get rid of the anonymous namespace. And this is the moon clock. I keep saying moon unit because it's moon something, right? The private properties of a moon clock instance. And we can leave that empty for now, I think. We're gonna put... I was gonna say we're gonna put the Lua interpreter into this, but really, this plugs into a Lua interpreter, right? So I'm wondering if I should just make the Lua interpreter something we give through a shared pointer. Then this would hold on to that, right? Hey there, Atomic Nibble. Are you turning into a feline? My cat was meowing at me earlier, and it turned out he wanted better food. And I said, no, you gotta eat the food that I bought for you. And then grudgingly he ate it. And then he's like, okay, let me out, human. And then I let him out, and now he's outside. He tells me this through meow, so it's like I have to interpret what the which meow is it? Which meow is it? Let's for now make that defaulted. We can default the movement stuff. We say copy is not allowed. Hopefully he won't kill me now. Yeah, in my sleep. He'll slash me in my sleep. You know it. There was some reason why I needed to do a default constructor. I think it had to do with when I build it on Linux. It didn't like if I left that out like that. But if I did that, then it was okay with it. And I never really got to the bottom of that. So, Oh, I do need a constructor for the outer class, I just realized. Because it needs to construct that thing, so let's make a constructor. This is the default constructor for the instance, or for the class. There we go. Okay, why did my bot restart there? Oh, we had a crash. That's why. Let me check something. Yeah, it's under stress. Let me Go ahead and restart that. Stop it. And then when something crashes, the orchestrator says, oh, well, that version's bad. Let's mark it bad and then not run it again. And I keep forgetting to go back and fix that. So I'm having to do it manually. I had basically going back in the back end and changing that to 1.28.0. And then the special file called versions.json, I'm going in there and saying, no, 1.28.0 is not bad. You can go ahead and run that guy. And then I'm restarting the cluster. Actually, let me look at the log file before I do that. I can't show this on screen because it's production environment. Yeah, we had a timeout. There was a new election. Did the server just crash? Looks like it was either killed or it crashed. It died. The orchestrator said it died. So there's some kind of crash. Why would it crash? Interesting. Its connection was broken to something, but it doesn't say which connection. I wonder if it's the connection to Twitch was broken. It just says connection closed, 1006 connection broken by peer. Oh, 11006 is a WebSocket code, right? Interesting. Wonder why that would have happened. So its connection either to my front end. Actually, no, I wasn't even connected at the time. So it must have been a connection to another server got broken. And that caused a crash? That's weird. Okay, well, let's restart it. Is it just a coincidence that it happens while I'm streaming? The only difference between when I'm streaming and when I'm not is that it's tracking that I'm streaming and then it's listening in chat. I mean, it's seeing chat. If I'm not streaming, usually my chat room is silent. I'm just talking while I'm waiting for the server to start up. Okay, it's starting up. We're reconnecting to all the servers. We're all connected. That default shouldn't be there though. Yeah, it just didn't refresh that for some reason. Okay, well, don't know what it was, but it's working now. Okay, back to normal. We need a constructor. Probably need that for Linux, but I don't remember why, but we can just default it. And we'll just leave the rest of it empty for now. I don't even know if I really need an instance. It could just be all static methods. Hey there, Piano Boxer. How are you doing? Okay, moon clock default destructor. Okay, copy constructor. Let's not allow copying. So I can remove the copy constructor. All right, move constructor. Why do I do it that way? You can never, I mean, that makes sense for this one, I guess. Weird. Trying to remember why I have this if here. Oh, that's a special one. That's why. Okay, so I don't need that. I can just say that this is standard move other impl, and that's done. And then if this is not the other, then do that, return this. Good. Okay, and then we're done for now. All right, that should get it to compile. as long as I include it in the main project. So let me do that. Main projects CMake lists should have an add moon clock. Hey there, Raz. 818. How are you doing today? All right. Should I have the test do something? Maybe not. Let's just build. Make sure that the skeleton works. What? Oh, the target's wrong. So this should be not JSON tests, but moon clock tests. And this should just be moon clock tests again. Right there. There we go. Oh, that should say moon clock too, not JSON. Yeah. Now build again. Moon clock, not tests. Can't link to itself. Pinched nerve is on the end. On the mend. What'd you pinch? I'm sorry that happened. I've had that a couple times. I actually had a pinched nerve in my back that never healed. So I have like a numb area in my back. Ulnar nerve. Ooh, I had that happen to me. Both arms. Were we talking about that in a previous stream? I remember talking about it. For me, it was that my chair was too high up, and so my wrists and arms on the armrests were angled so that it was pinching my ulnar nerves. Not with you? Yeah, so for me, that happened, and I started getting tingly in these two fingers, the little finger and the ring finger. And that's what the ulnar nerve is connected to. And so my solution was to lower my chair. And so that changed the, I guess, the pressure points, and then the pain went away. Stomach is still giving you trouble. You might have to see a doctor. Uh-oh. I'm sorry, Raleigh Monkey. You maybe food sensitive like me? I've started to realize that cheese, milk, dairy, and I think eggs too, are not good for me, allergy-wise. That's what happened too? Yeah, so, yeah, just repetitive sitting in just the wrong angles can, like, pinch nerves. You're leaning on your elbow too much? Yeah, that'll do it. I'm glad it's on the mend. Yeah, when it was happening to me, I'm like, oh crap, did I damage them? And now I'm going to be, like, tingly for the rest of my life. And it got better, but it took like a week or two. So yeah, Rally Monkey, you might look into adjusting your diet, or at least keeping a food log to see if you're sensitive to some kind of food. Of course, you can go to the doctor to rule all this other stuff out. And what else? Try to rule out if it's stress or not. That kind of thing. Because stress can give you stomach issues. Yep, but it's something I have to live with. I've had a sensitive digestion for like at least half my life now, and yeah, it kind of sucks. Yeah, you don't want to have allow nerves to get pinched too long. Like I have the nerve in my back, I think, got pinched because of me slouching while sitting, and it got bad. It got so bad that now I have a numb patch. Like I'd say it's like roughly circular, like maybe 4 inches, 3 to 4 inches in diameter, where I can't feel anything on the surface. So like if a fly lands there or something, I won't know. I'd only know if like something poked me there, and it would be the nerves deeper down can feel it. Yeah, pinched nerves are bad if they lead to permanent numbness. Yeah, it's sort of weird, sort of wacky. The ones for your arms and hands are the most infuriating because you use your hands and your fingers all the time, right? So when you pinch the nerves that lead to them, it's really, really annoying. Okay, so this is a shell of a program. So I hardly ever show this, so it might be interesting. When I'm going to do something with test-driven development, I set up a unit test, and if I know I'm going to have some common stuff, I'll have a fixture. For Google test, it's you override or subclass, however you want to call it, this base class, which I think the tooltip will show us. It's in Google Test, a unit test program contains one or many test suites, and each test suite contains one or more tests. When you define a test using the test marker, you don't need to explicitly derive from test. The test marker automatically does this for you. The only time you derive from test is when you define a test fixture to be test underscore F. I think they probably go into more details here. Well, they just show the same thing I have, right? What the test fixture does is whenever your test is about to run, it calls setup. Then it runs your test, and then when your test is done, whether it passes or fails, it calls teardown. So it's kind of like a nice set up an environment for a test and tear them down. The other advantage is if I had some other test within the same test fixture, this common setup and teardown is shared between them. So I'm going to be using it to set up the Lua interpreter and all that stuff so that all my tests can use the same setup. So I start with that, and then if I know what I'm going to be testing is itself a class with methods, I'll just set up a completely empty one. So for me, the bare minimum boilerplate is usually this, that within some namespace, you'll have a class, and I'll have the same name for the namespace in the class if it's a small namespace, like there's only one class in the library, or if this is like the principal class of the library. So like the first spot you go to, like this is the main class, right? And then I like to break up the methods of classes these days into what are the normal public methods, and then the special ones, which are usually tied together. I call them lifecycle management. If you look up like rule of 0, rule of 5, it's in modern C++, if you define a non-default for any of these 5, you're supposed to define all 5. Now, your definition could be to tell it explicitly that you don't want to implement it, and that's how you do this. You do it with an equals delete. This is basically saying we never want to allow the class instances to be copied. So no copy construction and no copy assignment. But we're saying we will have destruction and movement semantics. So that's the destructor, that's the move constructor, and that's the move assignment operator. We don't have to say how that's done here because this is just a declaration. But yeah, I like to keep all 5 together because if you need one, you should define all 5 according to rule of 5. Then we have the normal methods, and right now I'm not going to assume I need anything in particular, so it's just going to be the constructor. And we need that because instead of putting all the private member variables and private methods in the declaration of the outer class, I like to use this technique called pointer to implementation, or PIMPLE pattern, where we take all the private member variables and stuff them into another structure, and we don't even have to say what the internals of the structure are here, because we're allowed, if we use indirection, to just say we have a pointer to something, and we don't have to say what it is at this point. So that allows like a cleaner separation between the interface and the implementation. So that's what this is doing, and that's why I have these standard comments that's saying we're going to define what's in there later. Right now we just need to define that it is something, a structure, and then we're going to say that our only private member variable visible through the interface is that we have a pointer to our implementation. See how that works? So once we have the pointer to the implementation, the minimum that you need in the implementation is you have to define what's in that structure, and that could have its own lifecycle management constructor if its properties are complex. If the properties are just like integers, then you don't need any of this stuff. You can just use what the compiler does by default. So then the non-deleted lifecycle methods, these 3, are defined here. And then I need the constructor too. I forgot that. Constructor. Impl. New. Impl. All right. So I can't say equals default here because of one little sticky point. The place where you say default, saying like I don't want to define the body of that, just give me what the compiler would have given me by default. You can't say it here because at this point it doesn't know what's inside impl. So it's like I can't make a default destructor because I don't know what impl is. So this is a trick you can do. You can say, I'll define it later. That's what that means. And then when we define it, we can say, okay, now that we come to defining it, you just use a default. And that works because we've just given it the full declaration of the class. Is this similar to an interface in C#? Kind of. To make it a real interface, you would not even have like a lifecycle management, and you would just have methods, and they would probably be virtual. So you can think of an interface is even more abstract than this. This is abstracting the implementation, but it's still saying that this is a concrete class that has a life cycle. An interface would be one step more. It would be like, we're just going to define some methods that everything that implements this interface should have, but nothing else. We're not going to define any kind of life cycle implications or anything. It's kind of like in between an interface and a concrete class. It's, I call it an abstract class. Well, I shouldn't call it that. What would I call this? I would just call this the interface half of the class. You're defining, it's just deferring the implementation to the subclass. In a sense, yes, because my subclass, I guess you could think of it as this impl. We're deferring the definition of that. We're just declaring that, yes, we have an implementation. And to get to it, you have to go through our public methods and to construct it and destruct it, you go through the outer life cycle, right? And then we've deferred it to our implementation, where we just say, okay, here's what we actually are doing, and we'll have the actual properties here. So yeah, that's my current style of writing classes in C++, is to have this clean separation. So for instance, I don't have to say in here that we are using Lua at all. Here though, if I wanted to I wanted to call Lua functions, we're going to have to include the Lua headers. Combo abstract interface, sort of. I think that link that I showed earlier, oh hey there, Red Sky One, I didn't see you there. Your color is the same as Raz and starts with an R, so I didn't see that. But yeah, the link that I sent earlier, I think sums it up pretty well. It's just one way to do the pointer to implementation pattern in C++, is to have is to split your class in two, and the outer one you can call the interface, but it's really not abstract. It's just that the class has another side to it, which is the implementation side. Hey there, Meridium. How are you doing? Okay, so that's all the boilerplate, and I made sure it compiled, right? Yes, okay, it compiles. It doesn't do anything yet. Let's set up the Lua interpreter here. So I'm going to copy some stuff from Moon Unit. In the runner, we did this, right? Right, creating a Lua interpreter and all this stuff. Let's have that done in setup here. So I will need a Lua, and that's this. Properties. I'll just copy it with comments and all. So that declaration comes from these headers, which is pretty much the standard way you integrate Lua into C++, is you include the Lua's header files, external header files, inside of an extern C to make C++ digest it. Currently learning C++ in school, and you're just about to start a project? Nice. So this declares all the things for Lua. This creates a Lua state. Okay, I forgot. I need an allocator implementation. That's pretty boilerplate, so I'm just going to copy it from here. It's inside here somewhere, right? Yeah, there's the allocator. There's other stuff in here like getting tracebacks and all that stuff. I don't think I need this stuff about JSON though. Do I need this stuff about comparing Lua tables? Don't think so. I think I'll just stop copying after traceback here. And I'll paste it up here, I guess. Something else I think you should do in C++, especially if you're going to make some library that's going to be mixed into a larger program, is if you have global variables and types and they're not inside of an explicit namespace, let's say they're private to this file, do this trick. It's called an anonymous namespace. So these are global constants, but they're not in the global namespace anymore. They're inside of a obscured namespace the compiler will give it a name at compile time, and we can use it within this file without needing to know the name, as if it was a global. But to the linker, it won't be global anymore. It'll be inside of some randomly named namespace. It's kind of a neat trick. Finally start understanding it. That might be because I'm starting a project from scratch, and I'm kind of going through the boilerplate of it, and you can kind of see how I do it. So maybe I should do this more often. Like having a child just say, hey, you. Yeah, there you go. Okay, I don't need to know that. I need to know that. This is all from Moonian, so I'm going to delete it. Okay, so if you read about how you embed Lua into C or C++, it'll talk about how you need to tell Lua how to allocate memory, and you need to tell it how to read the program. So that's what this stuff is. The allocator is a wrapper that Lua requires this interface, and we're implementing it in terms of realloc and free. Because, hey, even though we're doing C++, it doesn't mean that we have to be prejudiced against C. The C-based realloc and free work just fine, even in C++. So you don't feel compelled to always use new and delete just because it's C++. You can use C from C++ just fine. Yeah, ultimately, Red Sky One, we're going to be making this program measure how fast Lua functions run. That's the whole point of today. All things inside of an anonymous namespace are semantically the same without the static prefix. And because, well, there's two things about it, right? You don't give it a name, so you don't need to use it. So later when I use Lua allocator, I don't need to say like XYZ : or even : in front. It just knows that, oh, I know where that name was last seen. It was seen in the same file in an anonymous namespace. That's one thing it does for you. The other thing it does for you is when the compiler is done with it, it actually puts a name here, you know, some obscure name, so that when the linker sees it, the linker knows that that is only a symbol within that namespace. And because it's randomly generated, it's very unlikely that any other module within the thing you're linking will know about it. So it's obscuring or hiding what you want to be sort of private within your file. So you would use it for global variables that should be constrained in scope to one CPP file. That's what this anonymous namespace is for. Hey there, Master Agent Miyazaki. How are you doing today? I'm just setting up a new library that I'm going to be developing into a performance analysis tool for Lua. So it's a C++ library that pulls in Lua. That's why we're defining a Lua allocator and a reader. And we're going to use it to, in any kind of scenario where we have Lua embedded in some kind of framework, that you would enable it to do this kind of thing where it's going to instrument all your Lua functions and time how long they take. That's the objective for today, but I'm doing it one step at a time. So we're still at the step of setting up a library that knows how to talk to Lua. So yeah, when you create a Lua interpreter, you need to this is called dependency injection. One dependency Lua has is you need to tell me how to talk to memory, how to allocate memory, how to delete memory. So that's what the allocator is, and we're saying, hey, even though we're in C++, we love C still, so we're going to use the C realloc and free. So the second thing you need is a reader, and that's apparent when we get down into actually running things. When you want to actually execute or load a script, Lua load has another dependency which you inject in, which is the reader implementation. The reader is something Lua uses to figure out, well, I want to read the script that I'm supposed to load right now. How do I do that? So it will say, well, here's me. Please put the script here, and then please tell me how long it is here. And you can either do it in one shot, or you can let it call it multiple times. So Lua will keep calling the reader until you return null. So I just say, well, let's just read it in one shot. So I take what's in a vector, and I say, well, let's just turn it into one big string, and then set the size to whatever that string's length is. And then if they call us a second time, we'll just say, no, there's no more. So null. Yeah, you should love C. Should not scorn C just because you're in C++. So we're going to need that reader. And then traceback is a really useful tool for when you call pcall, which I do almost immediately after loading a script. I'm going to call pcall. And it's this argument at the end is the Lua stack index of a C function to call if there's an error in order to generate the error message. And so we're going to use, I've grown accustomed to making this point to a C function called Lua traceback, which calls Lua L traceback to generate a stack trace. So if there's any error, we get a full stack trace of where that error happened. So we're going to leverage that thing too. It does a few other things, like the fact that the function you pass is going to be given the error object on the top of the stack. You can check to see, well, if there's nothing there, if it's null, then I mean, if you try to interpret it as a string and it's not a null string, you can say, well, let's see if we can call toString on it to get a string out of it. And if we still can't, it's like, well, we tried, but there's no error message. Otherwise, one way or another, we would have gotten a string. And then if, how did I put this? If you're able to get a string out of it, we include a stack traceback. Actually, why do I do traceback only if that's null? Interesting. Shouldn't I do that even if we get to here or here? I have to think about that. Do you think one should also know C in terms of learning C++? I don't think it's required, but it's just another tool you can use. I see too many programmers in C++ say, well, we can't use fopen or realloc because that's C, and you're not allowed to use C from C++. And I always think, oh, come on. You can use C from C++. No reason not to. I think it's because a lot of teachers who teach C++ are like, well, there's a way in C++ to open files and allocate memory, so you should just use those. And sort of a dogmatic thing. It's like, well, but if you're using Lua, which is a C library, there's no reason why you can't use the C memory allocation, right? No reason why you can't. So I also like the file APIs for C a lot better than I like the C++ file APIs. I always sort of get kind of like a weird feeling when I have to use the C++ streams API. Right, so it's a subjective thing. Some people really love the streams API in C++. Other people like me are kind of weirded out by it sometimes, and it's like, well, I feel more comfortable using the C file API, and there's no reason why you can't. Today your teacher told you not to use fstring. Well, did he give you a reason why? If he didn't, he's not a very good teacher. That's called dogma, when someone says, thou shalt or thou shalt not, and they don't tell you why. If he told you why, and the explanation was reasonable, then okay. Not slow as hell. Slow is sometimes not a property of the library itself, but how it's used or misused. Because it's C, not C++, and we learn C++. I guess. So he's super focused on just learning one thing to the expense of learning other things which might be useful to you. I don't know. Sounds like a little bit of a narrow-minded teacher to me. I would have said, hey, you could use fstring, but it's not exactly C++. It's not bad. Here's where you can go to learn more, but I'm going to focus on C++. According to most people, that's one way to look at it. It's like only 99.9% true, though. There's like that 0.1% of C, which is not legal C++. Like the fact that you can have a variable called class. Int class equals 5. You cannot do that in C++. You can do it in C, though. So there you go. That's part of the 0.1% of C that you cannot, that's not valid C++. It's sort of pedantic, though. I think for non-pedantic purposes, you can generally safe to assume that C is part of C++ works, right? Interesting thing. I don't know for this. I don't know this for sure, but I've heard a rumor that Linus Torvalds uses the word class for variables in the Linux kernel just to make sure that no one can ever use C++ to compile it. That's what I've heard, but I've never actually. I don't have any evidence to support that. The way streams are designed make them slow. They deal with things too low granularity. That might be. Yeah, I can see that. I kind of hesitate to make global judgments across the board, like saying that it's always slow. I could accept that, yeah, it's slow for certain applications and maybe not slow for others. Also, slow sometimes isn't a concern. If you're dealing with user input in real time, for example, how fast do you need to be? Humans are ridiculously slow compared to machines. So the machine, when it's doing stream IO, talking to a human, can afford usually being slow, right? Because they're humans not going to notice. And if you are slow in order to make your code more readable and less error prone, then that could be a good thing. All right. Enough of me soapboxing. Let me get back to this. We're going to create a Lua interpreter. We're going to connect it to the standard library. And let me do the teardown before I forget. That's Lua close. This one. Lua close. Okay. I'll probably want to do this other stuff in a minute too. Making a meta table that's a global so that a Lua script can access our library's facilities. Slow for typical use case, sure, if only send it 1 megabyte blocks of data. Right. I always, well, not always. What I try to do is consider what is the evidence. If there isn't any evidence, I'll say, let's measure it. Give me the implementation using Stream API and the one without Stream, like using fwrite, and let's run them and see how they compare. And maybe run them on, just to be fair, run it on Windows, run it on Linux, run it on the Mac, and try both debug and release builds and get like all the data and write it up in a blog entry. And then if anyone asks a question, is it slow and why? You could say, here's the data. I measured it on these platforms. And someone could find another use case where they use Stream API or fwrite in a different way for different size blocks or whatever. They might get totally different numbers. And then you'd have a way to say, well, depending on what your application is, here's evidence suggesting fwrite's better for you, or here's evidence saying the Stream API is better for you. And then you can kind of make a decision based on what you're doing and not just dogmatic judgments like Fstream is not C++, so it's bad, or the Stream API is just slow all the time, so never use it. So that's what I try to avoid, is that kind of stuff. I don't think I need this quite yet. This is enough to at least run, right? And let me make sure that it passes, as in doesn't crash. And then we'll go from there. Fstream is not C++, so it's bad. Anything not written in Fortran is generally bad. Well, I don't know about that. If my mom would have a thing or two to say about that. She's a Fortran programmer. Okay. I tease her about that too, about the fact that she used and probably still uses Fortran quite a bit. So apparently Fortran has been updated recently, relatively speaking. There's like for a long time it was Fortran 77, and they went to Fortran 90. Whoa, huge leap for Fortran programmers. Apparently that modernized it for a while. But now 1990 is almost 30 years ago, right? Yeah, the original Fortran was like 1977 or earlier. Yep. You have a huge hate for Fortran. Did you have a bad Fortran experience? I looked at it briefly and I thought it was kind of amusing. The relics of the past, like that in order to name something a variable, you had to, it was a subset of the alphabet, and then things had to start on specific column numbers because that's how the input was read into old machines. It was through a card reader, and it was actually a physical optical thing where your code had to begin at a certain place on the card, and so you had to begin on column 5 or 10 or something like that, and if you were off by one character like that, it would not parse because the reader would say, "Oh, there's a space there. I expect to see a letter for instruction or a variable name or something." Yeah, punch cards. I'm old enough to remember that vaguely when I was a kid. That my mom had a program that was printed out on punch cards. Hey there, Clayman. And at the time, it was fun to shuffle the said punch cards, but if it was a program that she actually wanted, she would have been horror-stricken if I had done that. How are you doing, Clayman? And Nuclehead, how are you? Oh, and Mean Clear Bombs, how are you too? That's what Python does too. And yeah, but imagine if not only did you have to line things up, let's say they had to be lined up to a specific column. So this was legal, but that was illegal because it's not exactly on column 8 or whatever. Actually, I messed that up, didn't I? I made it too many. There we go. My comment about Fortran unlurked you, huh? Success! Okay, so let's get down to business here with enumerating Lua functions. We're going to have an interpreter. Let's make some functions. So, actually, there should be global functions, right? So let's just call it and get a list out. Yeah. So we'll say expect. What do we expect to see? Let's expect nothing, and then we'll be surprised when there is something, right? So we'll call this moon clock. Enumerate Lua functions, and we'll pass in Lua. So obviously we're going to need to declare that thing. And, oh, my apologies. I don't know anyone in that location in the world, so I'm not going to answer it. It is probably a robocall. I get like a robocall a day nowadays. Okay. Enumerate Lua functions. Yeah, I was going to say, I think that we can just make this a class method. So that's static. And we'll have it take a Lua state. So for purposes of the interface, we don't actually even need to say what Lua state is because we're handling it by pointer. So we can use the same trick that I used for the impl. I can just say, there's going to be something called a Lua state. Deal with it. And for humans, we can say, forward declare the Lua interpreter state structure in order to correctly specify the interface without requiring the user to know the implementation. Just needs my social security number and bank info. He also probably needs me to go to Nordstrom's and buy a gift card for them. And if not that, a Google Play card. 8 digits of your 9-digit social. It's the Internal Revenue Service. Can you show that impl class again? Yeah, let me do that. So, hold on. Let's just make that void for now. So here is the first time we mention it. It's a forward declaration. The same way this is forward declared. We're saying that there will exist at some point, not now, but in the future, some structure, and we're going to give it this name. I also decide to forward declare it here and not here, because if you forward declare it here, then you're saying it's within the scope of this class. So the class has an impl instead of there being a global impl structure. Lua, though, it's global, so we declare it outside the namespace and the class. Anyway, declaring it is all you need to do in order to use pointers to it, either managed pointers like unique or shared pointer, or just a raw pointer in C. The actual implementation definition is in the CPP file, and it's whatever you want to have in it. I chose to put lifecycle methods in a constructor because I think I might need them, but I might not. I could have that empty too. It'll still work. That'll work too. Once I do that, though, then it's a full definition. Even whether or not I have any body in there now, it's now a full definition, and so you can completely link it and compile it. Because our outer class has a pointer to the inner class, your outer class constructor needs to set up that pointer, whether you make a new one or you pass it in or whatnot. So if it's a new instance, we're making a new impl. If it's move constructed, we're going to move the impl from the other one into ourself. Default constructor is fine because the default constructor will end up using the default constructor unique pointer, which is to call delete on the thing. So we're all good there. So you make calls to impl instead of the class itself. The outer will end up, if it needs to, call either inner stuff if it's state for the object, or it could just call globals. Like this enumerate Lua functions doesn't need anything from impl because it is a class function. It doesn't have any moon clock state of its own. So later we'll be doing functions which needs moon clock state. But this thing is sort of standalone, and I'm just declaring it within the moon clock class for convenience. Actually, maybe I should just move it out of the class. It should just be part of the namespace, right? Why am I declaring it in the class? Let's move it out. And then I can remove static. That's probably better, right? I just need to declare, like, what is it that it returns. Let's just make it easy for now. We'll make it return a vector? Unordered set? Does it matter? A vector, I guess, of strings. That means I'll need string and I'll need vector. All right. So then I need to give a definition of that. And then return something, and then that will be enough to get it to compile. Starting to understand it? Okay. That's good. Let me know if you have any other questions about it. Testing, what is this? What could it not? Oh, I remember this problem. When you use expect equals, you need to be explicit about the type. That's a shortcoming of Google test. All right, so this will run and pass because that is what it returns. But let's say we wanted to return more than just an empty set. Like, let's actually declare a function in Lua and expect that it exists. So, like this, that we make a string, push a C function, and then call set global, right? Where's set global? There we go. Actually, I don't need a string then. It's just push a C function, call set global, right? So we'll make a C function called, foo. And then we'll make foo be a function. So static int foo Lua state. I'm doing this from memory. Oh, inside of a C++, we have to do it this way, right? Const auto food equals a lambda that does that. and then return 0. Foo. So we should expect foo, right? So this will fail. And to make it succeed, I want to actually have this enumerate all the globals to find it, right? So is impl actually defined? Yeah. It's defined right here. That's how you define it. So we're inside the namespace. That's the class name, and then that's impl. So it should mirror exactly what you had in the header. Namespace, class, name of the structure. Namespace, class, name of the structure. And you have to do it this way. You can't repeat class moon clock because you've already declared moon clock. So this is declaring something inside a moon clock. It's a little bit of a strange syntax to have the double colon inside for the name of the structure. It's kind of like you're declaring a structure, but you're saying this is actually inside of something else, and we're just giving the full implementation of it. Also, foo instead of food. I fixed that, right? I think I fixed that. Yeah. Foo as in foo bar. It's just a made-up word. Yeah, well, this is sort of weird in C++ to have. Usually you would just do that, or if anything, you do that. But we're saying the compiler should already know what moon clock is at this point. We're giving it the definition of something inside of moon clock when we do that. So this only will work if we've already forward declared impl here. If I didn't forward declare that, it would be like, I don't know what you're talking about. You never told me about impl inside of moon clock. Not beyond all repair? What's not beyond all repair? Oh, it might be hungry. I'm a little bit hungry. Is that a Freudian slip to write food instead of foo? Okay, anyway, I want to enumerate all the globals, and I did something like this in the runner, right? Where I enumerated all the things under global. Yeah, here it was. So I'm just going to ruthlessly copy it. Paste. And change it to vector of strings. And we'll call this functions. Or function names, I guess. And we're going to return that, right? Okay. Where did I do the G thing? Did I copy from the wrong place? It would have been as a string, G, right? Sure sign of good code if you copy pasted it. I mean, maybe. Maybe it was good code. Colon isn't used for inheritance specifically in C++. Sure it is. Like that, right? The double colon is a namespace divider. So if it's up front like that, it means exactly what it means is explicitly in the global namespace. And when you have it between two symbols, it means the thing on the left is something that can have a namespace. Either it's a namespace or it's a class or a structure or something else. Something that can have names inside itself. You saw a colon, you assumed it was the same? Oh yeah. It's when it's a double colon, it's means the thing on the left is something that can have names inside it, either a namespace or another class. Yeah. That's kind of weird, right? If I had that, then it would be inheritance, except that it probably would require that I have a symbol there, right? Now it's actually defining a subclass of impl when I do that. That's not legal because it actually needs a token here, either public or private, right? So yeah, the syntax is a little bit funny. That's where you were confused? Yeah, I don't blame you. Oh, okay, where am I? I'm up here, right? I thought I had some code that went through all the globals. It wasn't these two. I thought it was in runner. Didn't we have something that... Oh, no. I used to have it, and then I changed it so that you have to call back to register a test. Okay. But it's the same kind of thing. We're going to go through the table. So I need to push... I need to get the table, right? It would be get global. I always forget this stuff. So I'm going to look it up in dev docs. Would get global? Yes. So we want that. So Lua push global Lua G. So that's a special table that itself has keys, which are the global variables. Am I missing something here? I am. The tests included the Lua headers, but the thing that we're testing also has to do that. The reason I do it here and not in the header file, by the way, is because technically this interface doesn't require that the code that's including it actually know what Lua is. It just needs to know there's something called Lua state. Don't know what it is. You don't need to know what it is. The interface doesn't need to know. The implementation does need to know, though. Hey there, Teston. How are you doing? Nothing funny about C++. It's serious business. That's true. Okay. We don't need this stuff, right? The table index would be -1, I guess. So that's... I'm using these inline comments to remind myself what's on the stack. So that means that's the key, and -2 is G, so that's -2. So then it's -3 is G. And we're taking the key and appending it, so push, whoops. Function names, push back, and then I think I just want to interpret it as a string, right? Lua test string, or toString? toString. There we go. -2 at that point. And then we're going to pop the value. Actually, I could pop the value first, right? Pop it. I can just do that. So -2. So now it's back to key and global. And then this goes back to global when it reaches the end. So then we have to do a Lua pop. And that should give me all the names of everything. How come it's failing? What? Push global. Oh, it's get global. Now, okay, now that I get the double colon thing, I see the matrix. Oh no! And I just saw that it didn't have my iPad out. So I don't know if any of my mods have been doing it, but I'm trying to use this featured chat thing, so let me get it back up and running on my tablet. I log into it. Hold on just a second. It's one of those things I forgot to do when I set up the stream today. Go into featured chat. So, this thing called featured chat. It's being developed, sponsored by Twitch. It's being developed by someone else on my stream team. And it lets you do stuff like this. Oh, that did the wrong one. Now it's all messed up. Do I need to reload this thing? And a staged nuclear heads one. There we go. The thing off to the right? Nothing funny about C++. Serious business. So, if anyone has a question that requires like a long discussion, my moderators or I will put it up on the bottom left there so you can see what the heck we're talking about. That's featured chat. All right, back to this. Serious business. Let's run the test again. Okay, we get a whole bunch of stuff out, right? I'm actually thinking of not pulling in the standard libraries, because then we won't have all this other crap. So let me see what happens if I don't do that. What global symbols do we have? It doesn't even load. Why is it not even loading? Why would it crash? Let's run in the debugger. That's weird. Is it telling me that underscore G doesn't exist? I think that's what it's telling me. Or did I do this wrong? Really? You don't have an underscore G if you don't include the libraries? Let me look this up. Maybe this calls something that I need to call. Opens all standard Lua libraries into the given state. Yeah, what if I don't do that though? Hey there, A squared. How are you doing? Just eliminating that as a possibility. Let's try this again. Yeah, we're getting an exception thrown right there. So is that telling me that underscore G isn't a valid global? That was a 1/10 of a second reaction time? I know, I was super quick. G, a global variable, not a function that holds the global environment. Lua itself does not use this variable. Changing its value does not affect any environment nor vice versa. Yeah, but how come I can't look it up right now unless I load the standard library? It seemed like 0.1 seconds, though. That's what counts. Secretly, I have a spy who knew that you were typing Raimu 8 Hey and told me about it a second before you typed it. So I timed my response exactly. This is really strange. You will never find my spy. Find original element. Yeah, I have never been able to debug inside of the Lua interpreter. But this is telling me what? The Lua next crashed? Lua next. Pops a key from the stack and pushes a key pair from the table at the given index. So why is it crashing? I wonder if I need to call this within a P call to figure it out. It got past the API check. Oh, that's weird. GC is CD, CD, CD? It's like it's not initialized or something. I wonder if that's the problem. If you don't call Lua openlibs, maybe there's something else you have to call. Let me look this up. There's probably something I'm forgetting to call. Why isn't it crashing? I know. I've always called Lua L openlibs. I'm wondering if that does something that like I should be doing now myself if I don't call it. This should find it. It just calls Lua require F. Where does that go? It's just loading modules. You hate Lua? I'm sorry. Lua could be the cause of trauma if you're trying to like make a World of Warcraft add-on or something, or deal with an add-on. You know, I'm gonna just live with it, including the standard library. I will just need to like enumerate all of the things. So what we expect in this list, right? It's also not sorted in any kind of way. So what if I turn this into a set first? Set. Just so that I don't have to care about the order. So first we'll say const auto function list is that. And then we'll have standard set of strings, function set, that we construct from the function list from beginning to end. And then I can say we expect the function set to have certain things in the set. And foo will be in there, but also, okay, which of these things are functions? Coroutine, actually I don't know which ones are functions. Underscore G is definitely not a function. Actually, I'm curious to find out which ones are functions, so let me change the code to only show functions. So it would be, we would check to see if it is a function, right? Lua get global. No, we already have it. It's a value. So is function, right? Right. So if Lua is function, Lua, the value is at -1, right? Right. So if it is a function, add it. Let's see, what do I get now? Run. Okay, so it's fewer things. So these are all the global functions that are in Lua, including the one we added. Hey there, Crumpet. And Zeralir. Nice name. Hi. You have heavy trauma with an add-on? I'm sorry. This might not be the right stream for you, though, then today, because it's all going to be about instrumenting Lua to do performance timing. So ultimately what this is for is the game I'm working on, where I have made a custom game engine in C++ with the logic. The game logic is driven by Lua scripts. So these NPCs and what they decide to do and how they act and stuff is all driven by Lua. And it's getting to the point where things are slowing down, and I kind of want to see why. So that's why today is the work is to make a reusable component, so not just me, but others could use it too, to plug into Lua and instrument all Lua functions and measure how much time it takes to run them, and then apply it to my own game by actually including it in the game server, letting it run for a while, and then getting the report out. We should see, oh, well, all your pathfinding functions are slow as hell. And then I'll have something to go on rather than just guessing. So yeah, that's what I'm doing today. Aircraft simulator for Warplane Mirage 2000 F14. So they also use Lua to drive the AI? Interesting. Okay. Thing is, if I include the standard library, then that's going to affect what my test expects, right? Do I want to list all the things that come with the standard library in my test, or do I only want to list the things? Maybe I run it twice, once before and once after I set the global, and then just take the difference, or the difference from before and after, and print out what it is. No, but I kind of want to see what all the globals are anyway. And it's not like these are going to change much. Yeah, let's just list them all. So we have assert. We have collect garbage. We have do file. We have error. We have foo. This is the one we added. We have get meta table. We have iPairs. Load. Load file. Set meta table. To number. To string. Type. And XP. I have never heard of XP call. I should look that one up. That's the one I don't recognize. XP call, what does that do? Similar to pcall, except that it sets a new message handler. Ooh. Wonder what that means. Oh, it like substitutes the current message handler with another one so you can nest them in some way? It levels you up. It sort of does. Sounds like it levels up the message handler for a protected call context. Never used it before. Anyway, this should pass the test now, right? No. I suppose I'm missing... Oh, I missed a whole row. After load file, there was next pairs p call raw equal raw get raw len raw set require select. Gosh dang it. I'm missing something. Ah, print. I'm missing print. Yeah, you're right, Toulouse. You are correct. Chilling, watching someone else work. Yeah, that's what a lot of people who watch science and tech coding streams are doing. They just want the voice in the background, either when they're chilling or when they're working themselves, and I think that's fine. If I start talking about something that's interesting, then maybe I distract you away from your work, and then you're procrastinating. Right, Toulouse? Looking at you. But I found that I do the same thing when I'm not streaming. I'll also have someone else on Twitch in the background, just because it's the social aspect of just hearing other people working is sort of comforting. And yeah, once in a while, they'll start to go on a subject that I'm like, I'm actually interested in that subject, and so I'll stop my work and kind of chat with them about it as well. You're the Jeff Bezos. He doesn't share any of his points fortune. Maybe. Standard lives info. I should look at that. What Sky One just linked. Oh, I shouldn't go away from dev docs. I have another tab here. Okay, what am I looking at? Yes, this is the standard functions. Is this telling me that G itself comes from the standard libraries? And that's why I couldn't enumerate G, because G didn't exist before? That's probably why, right? We think you're Santa Claus, of course. Have to be. You gotta be. Okay, so maybe that's it, Red Sky One. I'll give you a point for that. I was wondering why this code doesn't work if I comment that out, and I think it's because the G variable itself is from the standard library, because if Chapter 5 standard libraries, Chapter 5.1 basic functions, if G is in there, I'm guessing it doesn't exist until you include the standard library. So how come stuff like that isn't showing up in my list? Like getF and env. Is that not a function? Let me see. Let me take out this if again. Did it show up in the original list is my question. It probably did. It's just not a function. No, it's not even in there. So wait. GetF env is not defined. That's weird. It's not itself a global. Everything else is, including G. So what's special about get FENV? What's so special about it that it doesn't... Oh, there is this ... Does that mean there's more? But wait, there's more. Could it be the Lua version? This is 5.1. I'm on 5.2, I think. Ooh. How did I end up here? We're on chapter 5, right? Actually, the chapters are numbered differently. Standard library. G. Really? Is the structure of their manual different? How about get FENV? Oh, there we go. They were removed because of the changes in environments. So that's why it's not in there, because I'm using I think I'm using 5.2. How would I know for sure? I'd have to look at my own Git comments. Git log. Oh, I'm actually using 5.3.4. Thank you for that follow, by the way. So I should be looking at manual page 5.3. Why can't I search? Oh, there it is. Okay, here we go. So it's moved to chapter 6 now. Yep, these are all the things that I found, right? So this is going to be Lua version sensitive, it turns out. I'm okay with that. Also describe how to include, exclude libs. Right. Question is, can I enumerate global variables without doing this if G itself isn't declared, or G itself is not added until you load the standard libraries? I'd have to have some built-in way of Lua to enumerate global variables. What language has the most similar syntax to C++? I'd say Java. But it's different. And I don't know all languages. There might be a language I don't know that's similar to C++. Like, I've heard that D is designed to be like what C++ should have been or something like that. So maybe its syntax is closer? I don't know. Okay, we're just going to go with this and have this be the cost, is that we have to list all the things that are in the standard library. Let's put this separately. Ones we defined in the test. Let's say functions. Functions that come with the standard libraries. Note. We needed to include the standard libraries because this guy, actually this whole thing, requires G to exist in order to enumerate all globals. Thought JavaScript was somewhat similar? I mean, it depends on what subset of the language. Like, JavaScript classes are nothing at all like C++ classes. Like, the this keyword is so different that, like, it really tripped me up for a long time. But other parts of the syntax, like how you declare functions and variables, it's similar. But so is it's similar to C as well. Java's the kind of pain to optimize compared to C. Really? I guess. Because it's on top of a virtual machine. So you'd have to be able to pull in native facilities to pull in optimized functions, I guess. Java uses prototypes for classes. Oh, JavaScript, yeah. Yeah, so instead of It's just a different scheme, right? Instead of, I don't forget the technical term, but there's the prototype pattern, right? And that's what JavaScript uses. Prototype pattern. The creational design pattern, right, where you have a prototypical instance. Do they have a nice diagram? It's not a nice diagram. Yeah, so JavaScript, they should have it. Why don't they have it? Why isn't JavaScript an example? That's weird. If that's what classes are in JavaScript, you'd think that prototype pattern would talk about it. Anyway, yeah. C++ doesn't use the prototype pattern for classes. Java is like JavaScript, like cars, like carpet. Yeah. That's why I said Java, and I tried not to say the word script. Well, yeah. So JavaScript, everything being an object in JavaScript is similar to how in Lua everything is a table unless it's just an int, a number, or Boolean or null, right? Or string. There's simple types, and then there are tables. And then there's a special table called a user data, but essentially it's the same as a table. Anyway, let me get back to this. Enumerate Lua functions. Sure, that's a good enough thing. Now, what do I want to do next? Do I want to have it search tables recursively? I could build this up in segments. I can have an enumerate table. Enumerate Lua table. Technically, I think I'd want the table enumeration just to find all functions. Let's say enumerate functions in table. Enumerate Lua functions in deeply enumerate Lua functions in table. Can I think of a shorter name? I should also break my habit of using camel case exclusively here, because I think it's harder to read for people. What if I use that? Because there's no reason why I can't. And then it maybe is a little bit easier to read, and it really doesn't cost me much. In fact, I can even do it with this. I can just do that. No reason I can't do that. What's something shorter than that? Find functions in Lua table compositions. Or composite table. Composite Lua table? I have to get used to the mixture of snake case and camel case. Find functions in composite Lua table. I'm only going to do this for test fixtures and test names. I'm not going to do it for function names because I'm too used to that. So for this, I wanted to make a table that has two functions, one that's buried another table deep, and another one that's not. This is the first time I've done Lua optimization. I'm not even doing optimizations. I'm doing performance measurements. I'm not going to optimize. But hello, Figgle Frats. It's an interesting name. Yeah, today I'm working on making a library you can pull in with Lua to instrument and measure the time that stuff takes. When I use that for my game's backend scripts, then I'll be able to figure out what I need to work on. Still hyped anyway? I'm glad you're still hyped. I didn't want to kill the hype, but I didn't want to be dishonest. Okay, so I'm going to make a table first, right? So Lua new table. And that's it, right? I figured how to... I can't do this from memory alone. It's like I need to look this stuff up. Go to runner. There we go. Lua new table. Right. And there's it's raw set. It's push. Let me look up raw set. I forget the order. I always forget the order of things. Raw set. It's like raw set table. The value is on top of the stack. The table's at the given index. So you push the key, then push the value. Got it. Okay, key, then value. Hey there, Manez. How are you doing? The epsilon constant is useful for checking rounding things, especially rounding to 0. They have that in lots of different languages now, right? The epsilon constant. It's in C++ in limits, right? Include limits, and then you have standard numeric limits double epsilon. I guess that's the C equivalent. I thought there was a. There it is. There's the C++ one, and there's also double epsilon, which is the C equivalent of that, right? In float.h, small is such that 1.0 plus that is not equal to 1. So yeah, it's in lots of languages. Very nice. I'm doing okay, Manus. I'm kind of distracted today. There have been a lot of good questions that have been distracting me. Distraction is good, because we get to go over some things that help people out. But I need to yoink myself, so to speak, back to the task at hand. And this task is, I'm going to be setting up a table. Should I just describe this here? Set up a table with 2 functions in it. One directly in the table. Well, one... How do we say this? Directly in the table? And the other... Actually, let's back up a second. Let's say set up 2 tables, foo and bar. Have bar, or place bar within foo. And make foo global. Then place a function inside each function inside each table, and verify they can be found. There we go. Should I illustrate? Illustration time. So foo use the correct punctuation here. Bar, and there's this way, right? I'm trying to do the. Sometimes it's hard for me to do it this way. We'll call that Baz, and then we'll call the other one spam. There we go. Function. Table. There we go. Raimu 8 ASCII. There you go. It's like Adam art. Raimu ASCII. Just to illustrate for people who are watching, right? That's what I'm trying to do. So, new table. Let's do the inner table first, and then it makes that easier, right? Then key value. So Lua push string Baz. I hear something. Is it a beast? I think I hear a beast outside. I'll be right back. It's a beast. Look out. It's gonna get you. Meow. Beast. beast. The beast wanted inside. Okay. So let's call it Vaz. And then it's Lua raw set, and then I have to give an index. So let's keep track of what's on the stack. That's bar. Vaz. -2 is bar. Vaz. -2 is Vaz. -3 is bar. So this should be -3. And then we're reduced to this. Hey there, Tim. How are you doing? You guys should check out Tim's channel if you get a chance. Tim is working on his own game engine for a variety of racing games. That's his thing. And recently he was working on WebSocket stuff, which if you've been a long-time viewer of mine, you remember I was working on that a long time ago. And yeah, I gave Tim some log information from what my WebSocket stuff does with Discord because he's working on that. And yeah, I really like when I make log files of binary data, I like to have hex dumps because it's just something I grew up with, even way back, original PC days. I think it was, I can't even remember what it was, but seeing raw data as bytes and as ASCII is really useful to me. And so I try to include that in any kind of log stuff that I do now. So, and I gave that to Tim and inspired him to do hex dump logger. Nice. I'm glad it helped you out. Well, now you'll be living the good life of having hex dumps. Did you know that there's also a cool extension in VS Code for getting a hex dump? It is called hex dump for VS Code. So I can say hex dump that for me, and I got a hex dump of that file. It's not as nice as the hex dumps I'm used to having, because it doesn't have a divider in the middle, and I like to have that at byte 8. Without the divider, it's kind of hard. It's hard for my eyes to tell which byte number that is. If there's a divider right in the middle, I'd be, oh, that's the 11th byte, right? Good hex editors will do this, where if you highlight the bytes, it shows you the corresponding ASCII, and it's really, really useful in looking at binary data. Yeah. So even if you like didn't have hex dump logger, you could just output the raw binary, and then you would redirect it to a file and open it in the hex dump thing in VS Code. That works too. Totally put that extra space. I know, it's so essential, for at least for me, for my eyes to see what column I'm in. I don't know why they don't all do that. Okay, so yeah, I'm working today, Tim, on writing some, it's sort of like automation. It's something I want to run once before I run my game's scripts, and it will instrument every game function. So like wrap every function with a start timing, stop timing, and then the stop timing not only acts like a stopwatch, but it'll take the difference between the two times, and then the name of the function that we were in, and kind of put it into kind of a data structure that accumulates data over time, and at some point at the end, we can say, oh, give me a report of how many times every function was called and how much time it took on average and total and all that good stuff. So kind of similar to what you get with Visual Studio performance measurement, only this is going to work for Lua. The issue that plagued you is taking a reference to the frame header within the frame buffer, but the frame buffer could change. Right, I remember that, yeah. It was the pointer can change every pushback because it's reallocating, right? I think, doesn't it reallocate double the size each time you go to past the end? So it'll first allocate like 8, say, and then when you try to go to the 9th byte, it says, oh, okay, and now I need to make it 16, something like that. Yeah, I was there when you found it. Yeah, there was a sweet moment when you fixed it. That was cool. And I didn't even see it. I think I remember putting in chat something like, oh, I didn't even see that. Thank you for the follow, whoever that was. Okay, anyway. Yeah, so this test case I'm arranging here, I'm kind of coming about this at indirectly, but I'm building up these functions that can like enumerate all functions in Lua and then find functions within tables, because what I want my instrument to do is I want to say just instrument the entire interpreter. And what it should do is search through all tables and all globals and find all the functions and instrument every single one of them. And then it's going to be using these functions I'm building up right here. So this test case, the test case I did before was just give me all the Lua functions that are globals. So it does that. These are all the standard ones, and here's the one that I added here as a test right there. So this next one is a deep search within a table structure, or we call it a composite Lua table, where we have a table that has another table and a function in it, and the inner table also has a function. And essentially, I want to get back out bar and baz. The question is, do I want just the names, or do I want the functions too? Actually, I think what I want is a combination of three things. I want to know the name, I want to know the function, and I want to know what table the function is in. And then, so that triplet, right, that triple is what I want. So how do I do this? I think I'm not going to do this set comparison. I'm going to make sure that there are only two returned, and then one of them is bar and the other one is baz. And we'll have to test to see if the table it's in is what's expected. Yeah, I think I know how to do it. Hey there, Oblivioner. How are you doing? Let me give you a wave. I'll respond to your concha with Raimuade. Hey, I heard that they are exchangeable on the exchanges of highs. So I'm going to want a baz and a spam. Just two functions we're going to add. And then I'm going to want to take... All right, I was going to build the inner table first. So that's building the inner table. And then we're going to make another outer table, right? So make another table. Now -1 is foo and -2 is bar. Actually, the way I've done this, I kind of want to build... I should, since it's a stack, I should define foo and then bar, right? Yeah, I can flip them. Currently have 3 points. You do have 3 points. Okay, I think you flip things in Lua with insert, right? Moves the top element into the given valid index, shift, right? So I want to like insert it into negative. So Lua insert to -2, and that gives you -1 is bar, -2 is foo. And that's, we'll want to have the push string Lua bar. -1 is the string bar, -2 is now bar, -3 is foo. So it's supposed to be key value, and I had it backwards. What if I push... there's no way around it, is there? I guess just do another insert. Lua insert Lua to -2, right? So the -1 is bar, -2 is the string bar, -3 is foo, and then I can just do Lua raw set -3. So now it's -1 is foo. And then I can do spam last, right? So kind of like this. Spam. Spam, spam, spam. So that's spam. That's foo there. And that's spam there. And then set global, so we're back to foo. Hold on. I'm missing the raw set. and that's stack empty. That is C# unsafe. You're working with unsafe code now? I've worked with unsafe code. You have to mark things unsafe when they muck with native code. What is raw set? Raw set is a way to circumvent the indexer. So it talks about it here. It's similar to Lua set table, but it does raw assignment without meta methods. So if you do set table normally, it says, as in Lua, this function may trigger a meta method for the new index. So if you have a new index meta method set for the table, instead of putting the value directly into the table, it'll pass it to the meta method, and the meta method could do whatever. It could put it in the table for you, or it might toss it, or it might do something different. So if you know you don't want to call the meta method, and it's more efficient anyway, you just bypass the meta method check completely just by doing raw set. So yeah. Okay, you didn't hear it capture anything. So let me give a little bit of background on what a table is, because it's more than just a dictionary of keys and values. So foo is a table, therefore it's like a dictionary. It has, in this case, 2 keys. Those keys are strings, and the values are the corresponding things that those strings are stored in. I made the strings have the same names as the underlying things, but they don't necessarily have to be, right? You can name them whatever you want. So that's step 1, right? Step 2 is to understand that a table can also have special things in it called meta methods. So one meta method is, if I were to add it to the table and call it _ new index. I think that's the name. No, it's no capitalization. If that is a function, if I made a function like that, then if, let's say in Lua, I did something like foo dot x equals 42, then essentially what that does, instead of taking the 42 and making a new, this is what you'd expect, right? That it made, I'm perpetuating the ASCII art here. Instead of making a new key called x, which is an integer, with the value of 42, it doesn't do that at all. Instead, it turns it into what's equivalent would be foo dot _ new index x, the string x, and then the value 42. If you have that in your meta, actually, sorry, I drew this wrong. You can't have it as a key in the table. You have to have it in the key in the table's meta table. So I should back up and explain that. A table can have a meta table. So let's describe it this way. Meta foo meta. It doesn't there's not actually there's not actually a string called foo meta, but there is a table. There is a table which is assigned to be the meta table of foo. And within that, if you declare new _ new index, then so what happens when you do foo.x equals? Lua will do this thing first. It'll say, oh, foo is a table. Let me see if it has a meta table. Yes, it's got a meta table. Okay, does the meta table have a key called new index? Yes. So that means I'm going to turn foo.x equals into a call to foo. Actually, I guess it's foo meta. Like that. It'll turn it into foo meta new index and then pass foo, and then the key and then the value as arguments. So the reason for this is you might want foo to be not just any ordinary table, but an object. And you might want new index to do certain things, like maybe foo represents a JSON object. New index should say, it's not just going to put it into the table, it's going to maybe put it into what the table represents. So it's like it becomes an abstraction. I know you distracted me, but it's if for people not familiar with Lua, it might be interesting and informative, right? I don't completely understand it, Toulouse, but I try to understand it. And actually going through this right now helps reinforce my understanding. And if I get it wrong, someone will tell me. Yeah, essentially, the meta table lets you define behavior overrides. So you can think of a meta method, is what it's called. It's overriding what assignment means to do something else. Now, inside the meta method itself, you could end up calling raw set on the table, right? And then it's like you didn't need to have the meta method at all. But you could define assignment to your foo to mean completely something different other than putting it there. It could be ending up putting it, giving it a different name called like variable underscore x, right? So if that ends up saying foo dot variable x equals 42, then that's what happens, even though you did that, right? Let me remove that because that might be a little too confusing. If Lua goes to the table and says, do you have a meta table? Yes. Okay, does that meta table have a new index? Let's say I didn't. Then it's like, oh, okay, it'll default back to doing the raw, just sending it into the table directly. That's what raw set does. Also, if there's no meta table at all, it'll just set it. So you have to have both the meta table and the matching meta method for what you're doing, and then you're overriding the behavior. So the reason why, again, why I do the raw set is it's bypassing. We could have set a meta table. We're bypassing it. It's just more efficient. It bypasses the check to see if there is a table, and if there was a table, the check to see if there's a meta method for assignment, or for set, basically. So it's just more efficient that way. So yeah, we have no meta method. We have no meta table, so I really didn't need to do raw set, but it's nice to get into that habit if you start working for tables that do have meta tables, and you know that you're going to want to assign it directly into the table and not go through a meta method. I hope that all made sense. Yeah, meta table is kind of like a vtable. It's a little bit more than a vtable, though. It allows you to override pretty much every operation you can do with the table. So if you really want to know the whole list, I think you just go to the Lua manual and you just... How come I can't look up Lua? Do I have to actually find it in the list here? Fine. Where are you, Lua? There you are. Interesting, I don't have 5.3 enabled. 5.2, 5.3, same thing. They have a whole chapter on meta methods. Here we go. Meta tables and meta methods. And they have a list. So there's sub for subtract, mul. So like the equivalent, in C++ where you can define operator functions for a class. In Lua, you would just set these special meta functions these special functions in the meta table of a table, and then you've done the equivalent of operator overload. So that unary minus, concat, len, equal, less than equal, index, new index, which is the one I described. This indexing operation where you're assigning. And they distinguish index from new index. Index is when you're reading, and new index is when you're assigning or writing. And then there's call, which makes it really fun because then you can then call the table, and calling the table ends up calling the meta method's call method. Or the meta table's call method, like they describe here. In fact, here, they actually had the logic I described before, right? This is what Lua does internally. If the type of this is a table, then, hey, let's get the key, and if it's present, do the raw assignment. Otherwise, hey, let's see if the meta table has a new index. If so, or if not, call raw set. But if so, it's going to see, well, is it a function? Then call it. I didn't know about that you could do this. I always assume that new index is always a function. I guess if you have a new index that's not a function, it... What is this doing? Repeat operation on it. Is this because H... Oh, because H has been peeled off. Oh, I guess new index could be a table, and then new index into the new index table would just assign into the table. It's really weird. Lua is really freaking weird. I know enough of it to get myself in trouble. And I know enough to do raw set to avoid the meta table when I need to. Okay. I guess I'm leaving that comment behind because that's the structure of... And then we're getting rid of this, right? That's the structure of what we're testing here. Let me review this again. If that's bar, push string baz, push the function and its key value, so raw set sets that up, and then make another table foo, push the table to down, so flip the two, then push bar, then put that into index 2, then raw set, so that makes foo have a key bar which points to the bar table, so that's this. Then push spam, and then push the function spam, and then raw set, so that does this last one. Okay, so this sets up the table. And then we're going to, I wanted to call this like, yeah, this, but without the underscores. Find functions in composite Lua table. And what it returns is going to be a vector of triples. So it'll be a function info list. And I'm going to want to make sure that there are 2 of them. So expect equal 2 for function info list size. Because there should be 2 functions found, baz and spam. And so which one's which, we don't know. Should I sort them? Or I could just look, I can just get the index. Yeah, let's just do it simple. So size t, what are they again? Baz and spam. So baz index. Let's just assume this, and then we'll do a check. If a function info list 1 dot name is not equal to baz, then we'll flip the 2. Remove the size t and then do that. And then we can, now they should be, either way they should be in an order we can expect. Expect equal baz for function info list. Oh, I'm thinking of Lua indices, aren't I? Dang it. C++ indices. Name. And then the function should just be an address comparison, right? So I should just be able to compare the address function. And what was the third thing? Oh, it was the table it's in. So how do I know what table's what? I don't need that one, by the way. We know it's the bar table Y because I could look baz up in it, I guess. Yeah, so I would do a lookup. How to do this? Can I just push it? Now that I think about this, I can't put a Lua function back into a C++ table like this. What am I thinking? I could make this thing also produce a table in the Lua registry, and that table could have a mapping between an information structure or an index in this thing and the corresponding table. Actually, I should put the function there too, because I really can't do that, can I? All right. So does that mean it has to stay in Lua? That would actually be most convenient if this actually pushed a table onto the Lua stack that has the results. So this would be, we would just say expect 1. Expect we get, because if this is a Lua function, expect that it returns one thing. Right, and then we're going to call len on it. So this will be that now the stack has results. And then let me look up, how do you get the length? It's Lua lane, right? And that does not pop anything. Might trigger a length method. Is there a raw len? There is, look at that. That's what I want. Okay, so expect equals 2 for Lua raw len. -1. Okay. And stack is unchanged. So then how am I going to do this? I guess we're going back to Lua indices. And how do I get a key out? That's raw get, right? Yeah, so everything in the list will be a table. So we'll get the table, and then from the table we'll get the name. So Lua raw get Lua. Oh, I have to push the key. Lua push integer baz index raw get Okay, so this is -1 is baz index, -2 is results. So then raw get -2. Back to that. And then, oh wait a minute, no it's not. It gets replaced, right? Yeah, so it's -1 is results baz index. -2 is that. Okay, so then from that table, we're going to do Lua push string Lua name. Lua raw get again. -1 is name. -2, -3. So I want -2. So -1 gets replaced by results baz index name. Okay. That I want to then get back, pop it off as a string. That's Lua get string, right? Or toString? Yeah, okay. So then if, well, standard string name is Lua toString Lua -1, and then I can pop it, right? Lua pop 2 to get me back to results. If name is not equal to Baz, then I need to flip them like that. Okay. Again, you can see how IntelliSense is confused. It says it expands to Lua set top, but then it says, oh, by the way, Lua pop is not defined. But you just said it was a macro. It's a macro, but like part of IntelliSense doesn't realize that it's a macro. Weird. Okay. So that sorts out which ones should be which, and then I kind of want to have just a subfunction to check the results. So actually, what if I have a table? If I have a little table here, static vector of let's define the structure. Expected results entry, and have some stuff in it. In a minute, I'll define what that is. This is a constant. One reason why you prefer Visual Studio when you can use it, VS Code isn't bad, but you find VS superior. I should check to see if VS has the same IntelliSense issue. I can't do that really quickly, otherwise I'd do that now. All right, what's this going to have? It's going to have a name, and it's going to have... Well, not an... Hold on, what am I thinking of? Right. Name, and then... key. So this is... The table it's in should have this key. The function should have this name. The table the function is in should have this key, and then what's the other thing I want to check? The function itself. So that is Lua C function, right? Ooh, how am I gonna check that? Actually, yeah, the pointer should be preserved, so I can do that. The function should have this address. Do what works for you, but you're doing it wrong. Yeah, there we go. Spaces, not tabs? What? Yeah, I use spaces. Tabs are for the weak. So this will be ooh, the order matters now, right? Shoot. I should include the index. So Lua integer result in index. Index of the entry in the results. There we go. So this can't be static then, because it has to be Baz index is Baz, which should have the table it's in. Right, should have actually, can I just search for itself? Yeah, I don't need this. I don't need this key then. It should just search for itself. And the function should be Baz. And then this one is spam index, spam and spam. Spam, 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 spam. And what doesn't it like about that? Expected an identifier. Okay, why does it expect an identifier there? Because struct? No, it shouldn't need a struct. Yeah, but I thought you could do initializer construction this way now. Like you can say standard string ABC, and then you can say A, B, C. That's using the initializer. Thought you could do that. Oh, it doesn't. There's nothing that takes that. You can say like ABC 3. That works because there's a constructor that takes that list. Oh, you're right. Your name is missing. There you go. Tim's got it. And thank you for the follow, by the way. So, expected results. There we go. I did forget the name. Okay. So then this becomes for const auto expected results entry in expected results. Expect equal expected results dot name for well, we need to get the name. I haven't gotten the name yet. And the function for the function. So to get the name, we need to get that index from the results table. So Lua push, Lua push integer. Expected results index. And then remind myself that it's results. Entry index. It's kind of a long thing there. -2 is results. And then a raw get gets me results. Okay, this should have been there, and that is just that. Okay, and then from that table, we're going to look at the name. So Lua push string name. I think you saved me more than 5 seconds. I think you saved me more like 29 seconds, at least. Okay, Lua raw get again. I need to track this. I get into real trouble if I don't track what's on the Lua stack. That's 2 and that's at 3 now. So that's -2 again. So now we're reduced to now we have still 3 things on the stack, and it's this dot name. Then I can turn it into a string. So const standard string name construct from Lua to string. Actually, what am I doing? I can just do Lua. I can just put this in here, right here. Lua dot -1. It doesn't like that. Probably because they're not the same type. What if I promote that to a standard string? That's a string. That should be a string too. What's its problem? Oh, what is it saying? I don't know what it's trying to tell me. Oh, because that's not that's a standard string. I think IntelliSense be confused again. So the function, so at this point I want to do Lua pop 1 to get back to this. And then we're going to do that. And then I'm going to end up popping again, right? Or popping 2 things, actually, to get it back to the way it was outside the loop, which was results. This is function, or just say fn for short. And then I can't... Oh, yeah, how do I get it back out? I can't... There's no pop function or get function, is there? There's Lua push C function. There's no... You know, I could just call it and get its result. So I can just have these 2 functions push something different. What if I do that? We'll have this one do Lua push string baz. And this one push spam. Actually, let's make it do something else. Let's make it capitalize them. All right, and then I'll just call it. So I can't do an expect. I have to actually do a call. Number of arguments 0, number of results expected 1. So then it's that called, whatever its return value is, and then we can then we can expect it. So instead of a Lua C function, it should just be string. It should be Lua integer. No, Lua standard string. Function result. The string the function should return. Okay, and then just put that there. Function result for that one, and then pop those two back off to get the results at the top again. And then we should probably pop it when we're done, right? Stack empty. Clean stack. We're at the stack, all right, we're at stack empty here. Yeah, then we called it. We expect 2 results. Okay. So we repeat the same process for the second one. Go to spam index, look it up, get its, make sure its name and the function match. Okay, that's good. A lot of work to set up the test. Okay. So we need to define that. That is int that Lua state Lua. I need to document these. Let's document them. Return a collection of the, well, just say return the names. Return the names of all global variables that are global Lua variables that are functions. I'm probably going to change this, so I shouldn't spend too much time on this. I'm thinking I probably want to change this to like just enumerate Lua tables instead. And then from the tables, we'll find the functions in Lua. Actually, it should do both, right? In fact, this might, I might have a third one that combines these two. Enumerate all global tables and then find functions in each table in a composite way. Actually, I could just do that with G, underscore G, right? So do I even need this one? I actually don't even think I do. So maybe I'm not gonna bother documenting because I'm about to throw it away anyway. It was only really used for me to explore enumeration of the global variables. Now that we know G is a global variable we can enumerate, we're gonna do it anyway here. Okay, return. So this should be push onto the Lua stack a list of tables, each containing the following. One for every function found within the table hierarchy, within the hierarchy of the, oh, did I call this with something on the stack? I didn't. I should though. Yeah, I should. Instead of doing that, I think we'll just, yeah, leave it on the stack. There we go. Push onto the, okay, so there's no the parameter is just Lua. I know I haven't finished that, but let me finish this first. Lua. This is the state of the Lua interpreter to use. So pop a table off the Lua stack. Actually, it's not that it pops it off. I wonder if I should use the same format that this documentation uses, where they have like number of things popped, number of things pushed, and then whether or not an error is returned. You know what? I'm not gonna do that. I'll do what I was about to do. Pop a table off the Lewis stack. And search its hierarchy for Lua functions. Push onto the Lua stack a list of tables, each one containing the following, one for each function found within the table hierarchy. And then it would be name, the name of the function in the table containing it, or let's say the key of the function in its table could be nested. And then what were the other things I was expecting it to have? Still doesn't like that. Oh, because this should have been a string, right? Forgot about that. It should just be name and function then. So function. Do I want a reference to the table containing it? I think I do, actually. So I should have checked it there. Yeah. I forgot about that. Okay, so let me have table. Is table a reserved word in Lua? I don't think it is. Let's just assume it's not. The table containing the function could be nested. And then this is the key of the function in the table, in its table. The function itself. The purpose for this, by the way, and what I'm going to use it for, is that when we basically get all the functions that we can find in Lua, we're going to go take the function and wrap it, like I have here, prototyped. Once it's wrapped, we're going to need to know the name and the table it's in to put it back in like that. That's the well, we need to know the name for two reasons, actually. We need to know the name there, and we need to know the name for this assignment. And I'm doing it. This was prototyping. This was pseudocode showing like if it was a global. If it wasn't a global, it would be like that, right? So we need to have the reference to the table it goes in if it's not global. If it's global, you can also do that. You need to know the name of the table, both there and also there. Actually, I might want to know the whole path to it, actually. Yeah, maybe we'll include that too. Anyway, we're going to do that basically to instrument everything. And the second part of today's work, if I get to it, since I'm already 2.5 hours in, second part would be to actually do this thing and to implement this start and stop timing thing and actually test it on something. All right. Pop a table off the Lewis. Okay, so let's include in the documentation here that we'll have a path. Actually, that could be part of the name here. Let's just call it path. List of keys. How do I describe this? The list of keys of tables list of table keys to use to locate the function within the table hierarchy. I think that's enough to assume to let people know that if there's only one of it, then it's directly in the top table. If it's like two, then the first key is of the top table, and then it's expected to be an inner table, and then the last key is the actual function itself. Do I need to include the function itself, or could you just use the path to find it? I think this is just I would just do that for convenience, right? Anyway, this is going to have a path and not a name, so let me verify. So I could just update this. This could just be vector of strings, right? And then we'll just have to build it here, right? So it's going to be a table which has a length. So maybe I should have a helper for this. Didn't I have a helper in Moon Unit for this? Someone tells me I did. Runner. They have like a table, a list from Lua or something. Lua table. Compare Lua tables. Maybe I didn't. Enumerate keys. I thought I did. I guess I can write one. Should I make a separate test for that? Actually, no, I only need it for the test framework here. So let's just write it up here as a global thing. So Lua allocator, reader state reader, traceback. So let's write another one here. So this is going to return a vector of strings. Or is, yes, it is. Turning a list of strings in Lua into a vector of strings. So I need string and I need vector. Okay. Read Lua string table, string list. Lua state Lua. All right. So we're going to get one of these and return it. So this is the list. Return the list. So Lua raw len. Can I just actually include that here? My negative one, right? Raw len returns it, right, as a size. And it's already the correct size even. Okay, so yeah, they can just say for, I have to use indices. So size t I equals 0 I less than list size plus plus I. And then I'll have to say Lua push integer, right? I plus 1. And then Lua raw get Lua -2. Okay, so if I'm here, -1 is the list. And then that would be -1 is I, and then -2 is a list. So raw get replaces it, right? So -1 is list I, -2 is list. So then I have to get it. So list dot push back Lua to string -1, and I gotta do a Lua pop 1 to get it back to that. And it's not to Boolean, Lua to string. There we go. Again, it is defined. IntelliSense is just confused. Let me make sure I got that right. Oh, it returns it. Okay, I got it wrong. Oh, no, it does. That's correct. The raw get replaces the top stack entry. Pops the key, pushing the value in its place. So, yeah, okay. So that extracts it, and so we still have to pop it because Lua2string doesn't pop it. Okay, so then I can just call that from down here. Right, I guess it's not name, right? So it's path instead. And that should be path. So instead of doing Lua2string, we do that Lua. Actually, let's pass an index because it just seems natural to. And this would be list index. technically it's int, right? And then a safety trick I remember, this is a safety trick that I learned, that because indices can change, it's safest to turn it into an absolute index like this. By doing get top, add it, and then add 1, and now it's a positive number, and that doesn't change as you push things on the stack. So I don't need to track that -1 as list, so I just do that. For all we know, empty stack. So it's clean by the time we get to the end. Or stack empty, is that the convention I was using? Okay. So that returns a vector, and we compare it to this path should be a vector now. The function should have this path in the hierarchy. I'm not going to worry about wrapping that. So that should match now. Should have a function, then we call it, we get a certain result. Okay. Does this build? Does not build. Okay, it still doesn't like this. One of these is, oh, because this is not a vector anymore. This should be a vector. Baz is in bar, right? So that should be bar Baz. And then this should just be spam. There we go. Hopping off for now. A bit more to do before you start the night stream. Hope to actually talk with Discord tonight. Okay, see ya. Good luck, Tim. I might be watching your stream later, although today's a busy day for me. After I hop off, I gotta drive the kids' carpool, and actually after that, I might be hanging out in your channel. We'll see. So I might raid you, then run out the door and come back and watch you when I get back. Hope you have a good stream. Is it because it's sensitive about the comma? No, it doesn't like the conversion from size t to Lua integer where? Right here? Yeah. We should not use size t, it should be int. Well, thank you, Tim. Okay, got an unresolved symbol because I declared that function and never wrote it. Let's write it. Dun dun dun, time to write it. Okay, so we're gonna do the similar thing to what I did here, where actually, you know what? We should get the index too. This should have an index. And should I pop it off or not? Let's not pop it. So that means that initially it would be -1 is -2 is foo. But after we pop it, we don't really need it, right? So I can say Lua remove, Lua -2. Remove is like a pop from not the top, right? Removes the elements in the index, right? Okay, so that's what we'll do. So then we just get the results. We don't need the original foo table anymore. Or do we? No, we don't need the table anymore, right? Because we basically unpack the table into all the functions that were in it. Yeah, so that should be safe, right? Yeah. Okay, cool. So this shouldn't pop a table off then. That makes it, I like that better. So int table index. It's more in line with what Lua's internal functions do. This is the index of the table to search. This is the index of the table to search on the Lua stack. Or how about we say, this is the index into the Lua stack where the table to search can be found. Oh, I hate that the wrap doesn't work like that. Okay, so then this should say search a Lua tables hierarchy for Lua functions. Push onto the Lua stack a list of tables, each one containing the following. One for every function found within the table hierarchy. Okay, I like that. So this just needs to be added to here. All right, and then yeah, I'm just gonna iterate it the same kind of way. And I want to do the right thing as well with the index, which is to turn it into an absolute index here. If table index is less than 0, turn it into a positive one. And then we're going to do this trick here. Just that part. So the underscore g's become the table. So we have a key, which is initially nil. We're iterating through. We're seeing if it's a function. Okay, we need to start building the table, actually, the result table, right? So before we do this, we need to do a Lua push, a Lua new table. And that's results. So, right, the table is just results. And then we're returning 1, right? We don't know where the table is. It's not in our relative stack list that we care about. Right, okay. New table. Oh, I need to get the table. I forgot about that. Okay. Yeah, so let's get it. Oh, actually, no, I don't. No, I don't need to. I don't need to do that. It's just this index is not results, it's table index. So the next key in the table, using the table index, puts the key and the value on the stack. And if it's a function, is there an if Lua is table? There is. Okay, that's what I want. Do I want to support user data tables too? What is does table include user data? Is table. Okay, I don't know if it works with user data. I guess there's is user data. Do I care about user data? Maybe. Because for my game, I actually want to enumerate functions within. Actually, to enumerate, it has to support next. Right? Lua next. How does that work? It only works with tables, right? Or does it work with a meta function? How does that work with meta, with user data? Huh. Maybe I don't want to do next. Maybe I want pairs, because that will use a meta method pairs. Or maybe I'm supposed to. Okay. Is there a Lua pairs? No. I should look this up then. How in Lua to enumerate user data keys. Or just enumerate keys. That's only for tables though. Okay. Another way to look at this is does the manual talk about a meta method for next? add sub, okay, con len, index, new index, call. But that's not the exclusive list, right? Because there's also pairs. Hmm. I wonder if I have to do it raw, like I have to check, does it have a meta table? If so, does it have a pairs? If so, call it, like pairs calls it. And then you get back the function to call to the iterator, basically, the table and the first key to use, right? And then you're supposed to call it. That's weird. Why did it jump there? Anyway, you're supposed to call it and it's supposed to return the next key, right? I'm surprised that it doesn't say that next looks for. I guess next doesn't look at the table's meta table. It just only works for tables. Actually, that makes sense. If next only works for tables, it would make sense that I can't use Lua next unless it's a table. So if it's a user data, I can't do Lua next. I'd have to do it the way pairs does it. I'd have to do it exactly this way. I'd have to check if it has a meta method. If so, call it. It's too bad I can't call Lua pairs and have it do it for me. Is there a Lua L pairs? No? How do you call pairs? So Lua call pairs from C. I don't see it. Lua pairs from C. Pairs programmatically? It's sort of weird because normally you just call it from Lua. I gotta use the restroom too. Wait, I'm gonna take a break and I'll come back to this. Maybe what I'll do is at first I'll just make it work with tables, and so I'll just use the next. And yeah, so I'll say if Lua is table -1, then we're gonna do a call recurse. Maybe I'll have a third argument, which is the path so far, and then that way you can call it self-recursively, and the path can be start out empty. But I'll be right back. Okay, I realize that the test only has tables in it, so where is the test? My test only has tables, not user data, so I don't need to worry about user data until I make a more difficult test, right? Thank you, Nui. So I'm just going to make it work with tables right now. Okay, so else. So everything in a table could be a table or a function, otherwise we're going to ignore it. Yeah, I know, it's taking me a long time to get to this. I'm still, I guess this was really high level what I was going to do, but it's taking me a while just to figure out what functions to instrument. And we'll figure it out. Yeah, let me, to call this recursively and retain the path, we need to include some extra information here, right? So let me include, we already have vector. So let's have a standard. Did I just make it shared? I think I'll just have two versions of this function. Yeah, string path. So when we call it, so the outer one could be a shell for the inner one. The inner one shouldn't push anything onto the Lua stack. It should already be on the stack. So there should be the table index and results index. Search a table's hierarchy for Lua functions. Add to the given. Add to a result list of tables. Add to the result list tables, each containing the following, one for every function found, right? This is the Lua, okay, and then we're adding some more functions. So, results index. This is the index into the Lua stack where the table to which results should be added can be found. And path is shared. That's in and out. This is used to keep track of the current path through the table hierarchy. All right, and then I don't need a path here. This remains as it was. One calls the other, so it just overloads. So actually, then this doesn't need an int. This doesn't need to return something. This should return something. The number of values returned on the Lewis stack is returned. Actually, let me think about this. It doesn't, the way it's defined, it's not meant to be called from Lewis. I really don't need to return anything, right? So, yeah, I don't need to expect one. I can just call it. Expect that it gets pushed onto the stack, right? Yeah. Okay. So they don't return anything. Okay. So there's the one that gets to call recursively. That doesn't need to return anything because we know it's one. Because that's called internally, we've already done that once, so we don't need to do it again. So really it's just to set this thing up, then path, and then call it, right? So find Lua table index Let's do that. -1. Actually, I should do that, right? After I push it, so I can say const auto results index equals that. This is the -1. So that's folded together, it's just get top path. And this goes into there. And this is just return, actually don't return anything, right? Yeah. This is just setup for doing this, and this recurses, right? Okay, so recurse would be, we need to take the key and add it to the path. So path dot push back Lua to string Lua -2, right? The key. And then I call it again. So find in Lua table in the table index here would be the table is the value, right? So -1 results index path. And then when we come back out, we want to do pop back. And then when we get to here, right, we want to make a new table and then attach it to the end of the results. So I'll need to know the length at this point. That's Lua raw len. Okay, so const auto results index is Lua raw len Lua -3. Actually, it's results index. What am I talking about? Results. So this is now off of that stack. This is stack empty. Are all the indices based on results or table index? So yeah, it's the weird thing about Lua. When you convert it, like by taking by getting the index to the top and then referencing from the top, it's always going to be a positive number. And those don't change because it's their stacks count, like their stacks grow downwards. So top gets the index, gets the how does this work? Let me look this up again. But negative numbers are all like referencing from the top of the stack down, and it's what get top returns. What does it return again? Returns the index of the top element of the stack. Because indices start at 1, the result is equal to the number of elements in the stack. So 0 means empty stack. Right. So if you're given a negative number like -3, then to get its absolute index, you get how many things there are on the stack, add -3, and then add 1. So let's say that there are 4 things on the stack, and then you wanted to get the index of the third one down, you would end up with 2. Right? Is that right? Yeah, from the bottom. If the bottom of the stack is 1. Right. So, yeah, illustrate, right? If the top is here, let's have 4 things on the stack, right? And then let's say that the absolute index and then the relative index. So the absolute indices are counting from 1 at the bottom, right? The relative index will be -1 counting from the top. The idea about this is that if I push something else onto the stack, then let's say I push X on top of the stack, right? So I'll cause this to happen. X. Now that's at 5. Let's see what happens. The relative indices change. The absolute ones do not, because the absolute ones are counted from the bottom up. So I end up using negative numbers if they're ones I've been working with. They're like the working registers, so to speak. I know where they are relative. I don't need to compute their absolute indices. But when something's passed in like that, and if it's passed in as a negative number, it's going to become wrong the moment I push anything onto the stack. So I want to convert it into an absolute index. And get top always returns the absolute number of things on the stack. So in this case, it would return 4. So if I was given -3, it would be 4 minus 3 plus 1 to get the 2. See how that works? The math is funny because it doesn't start at 0, it starts at 1. And then the other way around, the top isn't 0, the top is -1. So blame the Lua guys. So this magic formula, get top plus the index plus 1. If it's less than 0, it converts from relative to absolute index. Won't the next have a problem due to the push nil before it? It may be. But I wanted to explain how that conversion happened. Why that conversion works. Okay, so you're saying the next here is a problem due to the push nil before it. Well, that nil is putting the initial key in place, right? And then next pops that key off and pushes. So this is like old key. And this is new key. And the new key is the next one after the old key. And if the old key starts out at nil, next is supposed to give you the first key. So the new key is the first if the old was null. So yeah, this pushes one on top, but then next pops one and pushes 2 more. So the way that they show that in the manual, you look it up, they'll have a -1 is the number of things they pop, and then they either push 2 or 0, depending on if there's an error or not, I think. Oh, no, it's if there are no more elements in the table, then next returns 0. So it pops 1 and then either pushes 2 or pushes 0, depending if there's something more in the table. So I do that check here because they also return 0. So I think it returns the number of things actually pushed. So probably it was returning 2, 2, 2, and then finally 0. So while we're in the loop, we'll have 2 things pushed onto the stack. We're always popping 1 off. That's why at the end, I always say that that's now the old key because we needed to pop the value off. We're left with the old key. We loop back. Now we replace the old key with the value and the new key. Or new value, new key, right? Unless I missed something. Positive are real. Like I was illustrating before, the positive ones are counting from the bottom, and they're pretty much absolute because they don't change as you push and pop things, right? Whereas the negative ones are always relative to the top, so as you push and pop, the top is changing. So, yeah. Does that make sense? Or did I miss something here? I always second guess myself when Toulouse talks because it's like he always catches stuff before I do. Keep trying to understand the Lua part more, but dealing with the stacks apparently just confused. Well, but it's you might have seen a bug. I don't know. I tend to, in the last couple weeks, I've tended to have bugs that you've seen first. So now I second guess myself. So let me go through it one more time. Putting on an initial null key, then doing next with the table, which is an absolute index because I made it so there. And that pops the old, pushes a new key, new value. We check, is the value a table? If so, okay, I didn't do this part. We're pushing back. Oh no, we're not modifying this stack, right? We're just plucking the key off and putting it into the path. Then we're recursively calling with the new table index is the top value. Same results index, which is also absolute, because I did that calculation there. And the path, right? So the results index is anchored. It's counting from the bottom. This is saying we want to recurse. Oh, wait. You're right. we need to compute it, right? Because this assumed table index, I guess I could move it. It'd be simpler just move it, like, to there. We're going to be doing get top more than I need to. I could do it in both places. No, it's gonna be a wash. So every time we start looking at a table, we're gonna compute its index from the bottom. So then this call, so there was a bug. See, Toulouse, you found it, sort of. That it's the negative number, and when we recurse into, we have to do that check to convert it back to an absolute index again. Otherwise, pushing this nil will make that one invalid again. I think we can give you credit because that negative. A moment ago, I had the code like that, right? That -1 would have re-entered as table index, which becomes invalid as soon as we do that, right? So it would have been a bug. So now -1 gets converted to absolute index, and then we proceed. Okay. We're popping the value at the end. If it's a function, we've recursed and taken care of it. If it's a function, what am I doing here? Oh, this should be results index, right? Get the number of results. And then we're going to push that as the new key, right? Integer results index. Key and then the value. The value is a new table. New table. So let me do this right. So that's what is this again? This is the length of results. Then the new value, then the new key. And then the new table. So top of the stack is now results. Or well, it's a new table. So I guess we'll call it results entry. -2 is the length of results. 3 new value. Because at the end, what I want to do is do Lua raw set. Negative. Well, no, results index. And that would reduce it to back to this again. Right. Yep, it pops 2. Raw set pops 2. Yeah, pops 2 pushes 0. Okay. And we don't do this anymore. Okay, so between these two, we're going to build up the table. So first the key, Lua push string name, and the value, okay, one at a time. Keep jumping ahead, but I need to be really careful about the stack stuff. -1 is the string called name. And then the value of the name is actually the new key, so that's -3. So I do push value. At this point, it would be -5. So we get a copy of it at the top. -1 is new key. 2, 3, 4, 5, 6. Stack is getting deep. And then Lua raw set. And here it's -3. So at that point, we're back to this. And we've set the name. And the other thing it needed to have was, what? Oh, not name, path. Shoot, I messed up. Oops. You know what that means? I shouldn't be passing around this vector at all. It should just be a Lua table, right? Oh, wait a minute. No, it has to be a new table every time. Right, because if we're just copy the reference around, then it'll all get screwed up because it'll all share the same table. Okay, so yeah, I messed this up. This should be path. And instead of doing push value, we want to like do the equivalent of what I was doing up here, right? What did I call it? Read Lewis string. So it's the opposite of that. It's push. So flip this around and do it up here in an anonymous namespace. I guess I could make it a testable function. So it's the other way around. Take a vector. We're gonna want to, let's just say, push it onto the stack. So that's const, right? List. And doesn't need to return anything. So it's gonna be like write push. Let's call it push. Lewis string list. And don't need that. So let's comment this. Say push onto the Lewis stack a new list containing the strings in the given vector. Param in list. Should I call it list vector? Because there's also standard list. I don't know. I don't want the names to get confused. What if we say push Lua names? How about we push... let's just keep it list. It won't be too bad. This is the sequence of strings to... really to convert into a Lua list. And there's no return value. Okay, so how do we do that? We do a Lua new table. So that -1 is now the list. And then we're going to enumerate. Right, so that, so the key, and then I need to push a value. So Lua push string list index I, and this should be I, yeah, it is +1, right? 1 based, I +1. So that Lua goes first, and we need a C string from a C++ string, so I need to do that. And then it's Lua raw set. Make sure I don't screw up the Lua stack. Whoa. Why did it comment out the line when I did that? That was weird. Okay, -1 is the list index I. -2 is I +1, and 3 is list, so it would be 3. And then that gets reduced to just the list again. And then we're done. We fall out the top of the stack will have a list on it which has the strings in it. Okay, that's exactly what I want. And that goes here. In place of this. So it's not the new key, it's the path. Right? Oh, and I should put onto the path the name. So that's Lua toString, where's the key? -5. And then path pop back when we're done. All right, let's see if I got this right. So, why isn't it like that? Oh, it's the same name. How about say next result entry? Next results entry index. Right. That one is results index because that's what we're storing. Okay, got it. Okay, so get the length of results, push it onto the stack, make a new table, push the string path, push the path table list itself. Actually, well, and before we do that, we put the name of the function onto the path as the last entry. So that new key. So this didn't actually... No, that did change. Pop it because by this point we've converted it into a Lua list and we don't need it on that anymore. Right, and then the raw set takes that value and that key and puts it into -3, that table, popping those two off. And then we take that value and that key and put it into the results. So now we're down to that. And then we pop the new value off either way. And now it's the old key, and then we loop. Okay, it looks good to me. And then this just assembles a path, an empty path. Makes the result on the stack. Okay, so right, new table, get the absolute index of it. Actually, I didn't need to do that. I could just say -1, right? Or no, I do need to do that. Make a new table, get its index, call the inner function. Got it. What's table? Yeah, the outer table. Okay. Try it out, see if it works. It's probably not going to work, right? Nothing ever works the first try. We're going to crash horribly, right? Of course it didn't work. And it... Okay, we got 0 and then it crashed. Okay, so... I suppose we should just step through it. Yeah, of course fail. Atom fail. That's a hardcore fail. Let's step through this. Debug, please. There we go. Okay. Table index is 2. Interesting. It said there's nothing in the table. Did I do this right? So I screwed this up. Somehow it didn't have anything in the table. Oh, wait. It's not a list, it's an actual table. No, that should have still worked. Yeah, of course. The next should have worked, so why didn't that work? Something's wrong here, I think. Here's the food table, right? Okay, let me start from the beginning. Make a new table called bar. Put Baz string on the table, put the Baz function there, call raw set. So far, so good, right? And make a new table, so that's foo. Insert it into -2, so foo's there. Push bar. Take -2. No, take the top bar and insert it to -2. Then set it onto -3. So that does that. Push spam, push function, do raw set. Then enter here. I didn't put a breakpoint there. I wonder if that index is wrong. It should be 1, right? Table index. Why is it 2? That's a problem, right? Why are they both 2? Oh, I need to add 1 to that. Don't I? No. It was -1 plus 1. And that's 2? But then... Oh, I know what I did wrong. That is negative coming in, right? And we push something. So we can't do that. I have to do it in both places. I gotta do it in both places. There we go. Run it again. It still didn't work. Okay, but I should get the correct index. Yeah, 1. I got 1. Okay, good. So table is at 1, results is at 2. Okay, so it went in this time. So it found a function. So what's the name of the function? It's spam. Good. Pop. The next thing, it's a table, so we're recursing in now. And this table is at 4. Okay. And we get a function. What's this function? Baz. So it's bar.baz. Pop it. We reach the end. Okay, so then we pop the path back to the top. And we're done, right? Oh, wait. Did I mess something up here? Did I accidentally pop the stupid function table off? No, that makes a new one, and it's assumed to be at the top when we get to the end. It is, right? From the point of view, this is stack neutral. It doesn't, at the end it's empty. The only thing left on the stack should have been the results. So it should have pushed the results on. Maybe I'm not understanding remove. Remove. Removes the element of the given valid index, shifting down the elements above it. Above it? Yeah. Not a pseudo-index. Pseudo-index means something else. So that should have just cut foo off the end, and we should have had the results. So why is it saying that I'm getting a 0, and then I'm getting a structured exception? What's the structured exception? Right here. What is this? Oh, and when it continues, it crashed. Raw len returns 0 for some reason. Yeah, the stack is corrupted or something by the time we get back. Can I call this again? Let's just say, just a sanity check. Const auto should be same as table index. Lua get top Lua. I shouldn't do it there. I should do it here. Should be. At this point, there's only one thing on the stack, right? So this should be 1. It's 2. Ooh. So how many do we have going in? Oh, but I removed the top one. I mean, I removed the bottom one. I wonder if I'm removing the wrong one. So if the top is 1, the -1 is the same thing. Why is it? I have a theory. It might be that I didn't set up the results table correctly. Can you check the type? Yeah, I should do that. I'm wondering if it's not good enough to do this thing. Push and then raw set. Oh, wait a minute. That's going to be 0. I need to add 1. That's the problem. This should be +1. That's it. Although it should have said that the length was 1, not 0. Because it would have assigned index 0, which you can do, it's just not going to count it. And then it should have assigned index 1, so it should have been at least length 1. Maybe just assigning it to the 0 index makes it no longer a list. It's interesting. It got past that initial check and it's crashing now there. So it got 2. So something else is wrong here. Push 1. Gets that, pushes the name, gets it by name, and then tries to turn it into a string, and it crashed there because it's what, null? It's null. So there is no name field in that structure. Okay, we're getting there. There should have been, oh, no, it's not name, it's path. Also, I didn't push the function on there. This is, oh, was this old code? Oh, no. It's, yeah. It used to be a name, now it's a path, so I don't have that. Shoot. I guess I can just check to see its length is either 1 or 2. Okay, we'll do that. We'll say if Lua raw len of -2 is 1, then we have the two things swapped. And I need to pop them, right? Yeah, I need to pop one of them. Lua pop. Back to results. And I can't compile because I'm still debugging. Okay, let me debug down to here. Hey there, radar art. I don't know what you just said, but hello. Got 2 things in the list. Okay, so are they the expected format? Let's see. Nope. What did I get? Run. It threw an exception. Throwing an exception, is it because it's null again? Wait a minute, where are we? Oh, probably because that was null. So, oh, probably I had the same bug, I bet, in the construction of that list, right? In this helper function up here. No, I did +1. New table. Push an integer. It's I plus 1. I starts at 0, so the first thing should be a 1. Then push the string in from that vector, C string, then raw set should set it into the list. Yeah. When did you start with programming? A long time ago. Yeah, a little bit faster than you, Toulouse. Sorry, I should have let you do it. I'm used to doing the commands myself. I should let you do it. I'm in my 40s. I'm a bit older than most people on Twitch. Let's see. So, I want to debug this again. It gets into here, right? It's reading the Lua list. Am I reading it correctly? Let me see. Well, how old was I when I started programming? 6? I think I was 6 years old. Something like that. And the programming when you're 6 years old is mostly just playing around with simple little toy programs. How old was I when I started programming for reals? Hobby stuff I did when I was in middle school, so I would say, what, 12? And then I started working professionally when I was 18. 17. I had an internship. If you don't start programming right out of the womb, you're too late. If you start as a teenager, can you make big things? Of course you can. It doesn't really matter when you start. It matters about how driven you are and how much time you have and effort can you put into it and how much do you enjoy it. There are a lot of variables. I don't think age is not such an important thing. Just type right onto a keyboard. I think I have some bug here, right? That's one. It should get key 1, push path, get the path, and then, oh, wait a minute. I did convert to an absolute index. It's 3. Is that right? Yeah, because that's 1, 2, 3. And where exactly is it crashing? What is I set to? 1. Oh, no, that's correct. No, it isn't correct. Is it? Wait a minute. Why is it 2? It put empty string first. Wait a minute, what? Hold on. Spam was what level? Oh, I'm off by 1 somewhere. How come I can't think of this? It should be coming to me, you know? Hold on. Oh, why did I do a pushback? Okay, that's the problem. I shouldn't be doing a pushback. I already pre-allocated the size of the list, so this should just be list I equals. Yeah, I'm just being dumb. Okay, got further. Why did I get unexpected error? What's that? Does that mean it crashed after those problems? Yes. Crashed right there. Oh, Lua threw an error. Why would Lua throw an error? ToString failed. Where? Okay, I think I have them backwards. That's the problem. The logic here, match. If we assume Baz is at 1, and we check that, if there's only one thing in the... Yeah, the one that has one thing in the path list is spam. So why did it give me this result? Let's go to here. Oh, that passed. Hold on. Maybe I messed up the stack here. It's that call that broke. Right. Okay. So that call is broken. So maybe I'm not understanding the Lua call thing. Number of arguments. You must push the function, then the arguments, then do call. Number of arguments is so it's 0, right? Right. So it should pop the function, right? Right. It should pop the function and push the result. Oh, and then I popped 2 instead of 1. Is that the problem? Because after there, it should have. No, that's right. I just forgot to comment this line, although it's really, really long now. Oh, wait a minute, no, I did do it. Sorry. It's dumb. It will have been replaced by the return value after the call. Why isn't it not, though? It threw an error. Can we see the error? The type error. Attempted to blank a blank value. Is it attempt to call? Yeah, attempt to call a nil value. Okay, so it thinks it's nil. End results is 1. Okay. So it thinks it's not a function then. Oh, I forgot to do that part. I forgot to put the function in the table. I was also preoccupied with putting the path in the table. I didn't put the function in the table. So we put the path in the table. I didn't put the function in the table yet, though. Path is in the table right there. So let's put the function in the table. Push string Lua function. So now it is fn, and then the function is the value, right? So it's in -4 right now, so I want to do a Lua push value, Lua -4. So that takes what's at 4 and puts it on the top as a copy. So then -1 is the new value. Function results, all that junk. And then another set -3. And then a set results index. And then pop the old value. Okay, good. It's maddening sometimes working with Lua. Okay, we're getting it down to the function called is the wrong function. Okay, it did spam instead of Baz. What did I do wrong? Baz is Baz, spam is spam, spam, Baz. Called the wrong function? Oh, come on, I didn't expect that. Oh, wait a minute. It flipped them. The two are flipped completely. So there's something wrong with this length check then. Because I was like, if it's length 1 if it's spam, right? So that means I got it backwards. So then I would reverse it. So let me step through this. So it's going to push 1 onto the stack, and then it's going to get results 1. Oh, wait a minute. Why did I do -2 there? It should be -1. The length of the top of the stack. Yeah, that's the problem. All right. Last problem. Yes. The last problem has been fixed. Okay. So we got a function now we can call that searches through a table recursively and finds all the functions. Now we can pull that all together with the global, and that this should be fun. All of these, actually, what would we get? You know, I should probably replace this garbage with just something that, like, given a path, it finds the matching table entry. How would I do that? Can a vector be used as a key to a map? An unordered map? Don't think so. We can see. Can you make an unordered map? Standard unordered map. Can you make an unordered map where the key is a vector of strings? And the value is just an expected results entry. Can I do that? Expected results try. Is it going to give me a problem with that? Can't do that. Okay, but can I do it with a map? I bet I can't do it with a map either. I'm going to be sad. Oh, it actually, you can? I'm shocked. So you can have an ordered map, but not an unordered map where the key is a vector? So I wonder what the vector comparison looks like. Actually, why do it doesn't matter to me, right? So, yeah, right. So I can reorganize it to be this is the key, and the value is just what the remainder of it. So it's just reordered a bit. That's now the key, and that's the value, and that's expected results. And what I can do is I don't need to do this junk up here. This stuff here, I don't need to do this. All this junk. And there doesn't need to be an index. So it's actually just the result. Okay, easy peasy. Then instead of looping through expected results, we would loop through the length of results. So const auto num results equals lua len lua -1. So then for size t I is 0, I is less than num results. Actually, let's do lua integer, because that returns a lua integer, right? Wait a minute, what? It returns void? Oh, it pushes on the stack. I want raw len. Right, raw len. That's going to be a size t. So let's because raw get. Oh, it's just it takes an int. Okay, so let's convert it into an int. And we'll just say that's an int. And while it's less than or equal to num results, then I don't need to actually actually, no, I do want to extract it. It's push integer I. Actually, let's replace all these places. There we go. And then get the path. And then say, instead of expecting, we'll just search the expected results. Const auto expected results entry is expected results find that the path. And then if, well, let's get the path separate, right? So let's say const auto path equals that. And then we can, that way if we can't find it, we'll do, we'll expect. So let's do expect false that this equals that dot end. And if it fails, then we're gonna shift out path so that the return the debug message will say what path is missing. Actually, we can say extra function found. Shift that out, right? Okay, and so this entry dot becomes, actually it's just arrow, right? And then there's no path in it anymore. Do I need to pop anything? Yes. Pop the path, right? Then push the function, call it, and expect that function result. Cool. Okay, something's wrong. Function result is not a member. It's not? It's a member. Oh, isn't it? It's second dot, right? Yeah. It's funny how map iterators work. Oh, is it now going to tell me I can't do it? Oh no, it's saying shift out doesn't take. Oh, because this is what's path again? It's a vector. Is it saying that I can't shift out a vector? Is that what it's telling me? Yes. So, but I can turn it into one by I have a little cheat thing I can use. Oh, this isn't in order anymore. Let's fix that. All right. So, I have a little utility called join. So, system abstraction string extensions. I have a little utility called join. So I can do system abstractions join that with a dot. Okay, and then this should still run. But now if I comment out one of these lines, it should say I have an extra function called spam. Oh, no, it failed. Oh, yeah, this should be assert, right? Yeah, extra function found spam. So, and the join should make it do bar dot baz. Yeah, there you go. And then I should have a final one for if there are any extra ones, right? So the way that works is when we get down to the end here, we'll do a expected results dot erase entry and ignore the return value, and then we'll have down here at the end expect true expected results empty. And I suppose we can shift out like extra entries or functions not found. Just make this really pretty. Why not? Because I feel like it. Functions not found but expected. And then we'll have system abstractions join with a comma. I need to get the keys of the map that are remaining. So let's make a helper for that. Because I don't think there's anything built in to map, right? C++. How come it just type in map? There we go. There's nothing that just gives me the keys, right? As a vector. That would be cool if there was. I just have to get them out, right? So let's just call it keys of expected results, comma space. And then we'll just have to make a helper that called keys here. Blah, blah, blah. So this is going to return a vector of strings, keys, and then the type is a map of stuff. Actually, let's make a template that does this. That would be cool. Maybe I can make this reusable here. So if this is a template, class T, standard vector strings keys map, and then because I don't really care what the type is, right? And that's a const reference. Collection, I guess we'll call it. Or can I just call it map? I can call it map, right? And that's too long, so let me do that. Okay, and so the way we do this is we have the vector we're going to form. We can pre-allocate it, right? I can say keys reserve map size, and then I can say for a const auto entry in map, return keys. And I can say keys dot push back entry dot first. There we go. Nice little helper. I didn't like that. Why not? It is saying what? Cannot convert something to something. String to what? Oh, I gotta join this. System abstractions. Colon join that with dots. There we go. So this is a particular keys that works on a map of vectors of strings and joins them with a dot. So that might be a nice little utility. So it'll pass, and then let me test this by having found but not expected. So that should be if we comment this out, right? Oh, wait a minute. Found but not yeah. No, it's not found but not expected. It's things that aren't found. So if I had another function here, like should not be found. Now it should say, it shouldn't say functions not found, but yeah, functions not found but expected. That's exactly right. There we go. And then if I made something in, let's play around with this. Let's turn the underscores into comma that. Should join them. Has it been 4 hours? Jeez. I haven't even gotten to the subject of today. And then let's have a second one. Bad food. Thank you for the follow, by the way. I'm sorry I'm not getting to the stuff I expected, but see, I wanted to get nice things printed out. I'll end up using these utilities later anyway. I'll go for another half an hour. I'll just eat a little bit later. I want to try to get some of the profiling stuff done. So now we have a function that can find all the functions in Lua. Now I want to have something that will instrument them. And then we'll just let it get run, and then we'll just be collecting data. So the way I was thinking about doing it is we would have some instrumenter that we have access to. And then some way to instrument. So I think what I'm going to do is when we make... actually, you know what I can do is when... this would be instance data, right? So we can require that they make an instance of moon clock, and we'll just have we'll have an instrument, and then, or do I want to be controlled from Lua? I guess I could do it either way, right? So I can both have the instrumentation controlled by C++ or from Lua. See ya, Toulouse. Sorry I didn't finish by the time you had to head out. I wonder if I should finish this tomorrow. Leave the fun stuff for tomorrow. Let me see how far I can get. I don't think I'll finish, so we'll have some fun stuff tomorrow to finish. Void start instrumentation. We'll need to have a Lua state. And then stop instrumentation doesn't need it because we're just going to end up sharing. Oh, I was going to share it. Let's make it a shared pointer. We're going to copy it, so let me think about this. Yes. Yes. Okay. All right. Comment. I'll document these later. Let's make some unit tests. So these will go at the end, right? And then I don't know. Should I just say report? And what should the report be? It'd be convenient if it was just a sequence of lines. Actually, I should just make a structure for this, right? So report, generate report. So report is a new type. Struct report. I think for now I'm just going to make it a bunch of lines of text just to get something going. So it just has a vector of strings, lines. So that's what the report is going to be right now. And this should be const. Okay. And here's a little trick. Normally you'd have to do that. I don't like being redundant there, so there's a different alternate way to do the return value. You do auto, and then you do an arrow, and then you do the type, and you can remove the class name in front. Isn't that spiffy? And then I can say report. Actually, you know what I'm going to do? I'm just going to say return impl report, and I'm going to expect that we have one of these here. All right, and then, so start instrumentation. I think what we want to do is what I had in the plan. We're going to enumerate all the functions, and for every one of them do this stuff. So I think we're just going to do it all from C++. Alternatively, I can make something like this in Lua, but then it's just going to end up re-entering C++ anyway. So we're just going to have a wrapper generator. Okay, but let's do the test first. Okay, tests. Instrument. I don't know. Single function. Okay, so the instrumenting of a single function would be, we expect to make a moon clock. And with the moon clock, we're going to say start instrumentation with our Lua interpreter, right? And then we're going to call some stuff. And then later we're going to say moon clock stop instrumentation, and then we're going to say moon clock generate report, and const auto report equals that. And then we're going to expect some things. So expect equal some things. I can't type. Standard vector of strings for the report dot lines. Okay, what lines do I want? How come I don't have a Lua? Oh, I need to tell it I'm sharing with it. Okay, so that's a little tricky. We know it's within the lifespan of this function call, so I can manufacture a special shared pointer for this. So standard shared pointer Lua state shared Lua is Lua, but with a special deallocator Lua state that does nothing. There you go. You should only do that when the thing you're giving it to is guaranteed not to live longer than the thing you're wrapping. Otherwise it's kind of dangerous, because you could be giving something temporary to something that it might end up using it longer than it actually exists for. Oh, sorry about that buzz review. I'll wave hello to you. But yeah, we've had problems with new accounts in the past, so they get timed out right away, just as a precaution. Well, we can give them, I'll unban this time. In the past, we've had a lot of trouble with new accounts coming in and spamming. I'll leave it up to my mods to handle it. So I removed the timeout. Is it a little aggressive? I have to rethink that. I mean, what do you guys think? Should brand new accounts be able to chat? Or should we put some kind of precaution in place? Right now, it doesn't ban them. It just times them out until their account is a week old. But I can selectively, like I just did, I can unban them. Half a week seems... A week seems at least half decent. I know the pattern you're seeing was a month. Yeah, so right now, accounts a week old or newer are timed out. But I could relax that, and I can say as long as it's a couple days old. So yeah, sorry, Buzz Review. I untimed you out. If you want to chat again, that's fine. Maybe a few days, yeah. Or I could just lift it. I could put the thing in place again when and if I get trolled again. All right, back to work. Yeah, so Buzz Review, if you want to chat, you can again. Sorry about that. What do we want to have reported? We can just test that it got called. Foo. Let's have it like print something when we call it, and we'll call it 3 times. So before we instrument, we have to define it. So let's do a Lua push string foo. Haven't been able to mod directly. Oh, you don't. That's okay, Raleigh Monkey. It's actually been kind of smooth going for the last few weeks, right? So chat, the reason why I put the stream helper bot auto timeout stuff in place is for a while there, like I would get trolled like almost every day. And so it was getting so distracting and it was so easy to do to make a stream helper anyway, I went ahead and did it. So I have a bot that sits in the channel. Here's the screen that I get, and new accounts show up in green, and sometimes other things are marked. And one of the things it does is tries to detect when that kind of those kinds of problems that we were having in the stream earlier come up and kind of mitigate that. So I kind of left it on, but now that things have quieted down, I could probably ease up on it a bit and put it back in place if the trouble happens again. So yeah, we would have weeks where every other day we get trolled, for something. All right, push string. Yeah, you can go ahead and use featured chat if you want, Rally Monkey. Yeah, all my mods and a few VIPs too have that access. So key and then value. So push C function. So we're gonna have to make a function. We can have the function do whatever we want. Actually, just have the function do nothing. We'll call it foo. We'll have it return. I'll have it do nothing. So push it and then Lua set global. Oh, wait a minute, I don't have to push the name. I can just say push Lua foo. So then once it start instrumentation, we would be able to Lua get global and call this 3 times. So for size t 0 to 3, get the global and then call it 0, 0, right? How come it didn't like that Lua call? I don't know. So we're instrumenting at this point. We call it 3 times, we stop. Actually, let's call it one more time before we instrument. And then one more time after we instrument. And expect that we only get 3 report lines instead of 5. Right, so this should fail right now because it won't return anything for the report. Okay. I got like 20 minutes. How much more can I get done in 20 minutes? Did I scare Buzz Review away? I didn't mean to do that. You said hello. My bot timed you out a little bit too aggressively. Sorry about that. Feel free to chat. Okay, we need to have this do something. So the whole goal of this was to take the function I made before, this find functions in composite Lua table, and use it to instrument. So we're going to call it using the global table. The table of globals. Get global G. And then call it. And then we'll get back onto the Lua stack that list of functions, right? So we're then going to go through every single one of them and instrument it. And the stop instrumentation has to do the same. So we're going to want to keep track of a bunch of stuff. So I'm not going to test stop instrumentation yet because it's a little bit more work. We're just going to fit things in place. So we're going to loop through. And I looped through, like, where did I do that? In the unit test, I had a loop to loop through a Lua table. This thing, right? Get the raw, right? Get this stuff, exactly. So, okay. So we know if we know it's at -1, then const auto function list is get top plus -1 minus plus -1 plus 1. So it's just that. And then we can get the length of it and then index through it like that. Actually, why am I bothering to do this? Why did I do that? I can just say that we have it. That's -1 now. So here, the -1 is the globals. Now, -1 is the functions, and then -2 is the globals. If I wanted to do it, I can just remove -2 right away, but I think I'm just going to, at the end, Lua pop 2 to make the stack empty. And then in the meanwhile, we're getting the length of the functions. Actually, do I need to do that? Yeah, I'm going to make a table, essentially. So it'll be functions. Just call it functions. Actually, I ought to call this inside of impl. Yeah, let's take this whole thing and make it inside of impl right here. Like that. I don't need Lua. Do I need Lua? I don't. Well, I do. I know. Okay. Sorry, I keep going back and forth. That. Hold on. That I wanted to store here. And I wanted to say, I think I wanted in the outer to, is that the right way to do it? Probably this is the better way to do it. Say this Lua equals Lua. And then, because we're going to keep it for the stop one. So this is just going to say impl start Lua. And the same, let's do the same thing for a stop. And then stop has to have a function. The reason why we're keeping hold of Lua is so that I can make use of it during instrumentation. I don't know if I'll actually need to. Hey there, Crumpet. How are you doing? That's okay. You don't have to be here all the time. It's nice that you stopped by. Don't mind if you're coming in late. I'm actually over time right now. I gotta go in like 17 minutes. 20 minutes or so. My goal today was to build up some instrumentation for my Lua script so that I can measure how long things take. It took me 4 hours just to get the list of functions out of Lua. So I have now something that, how's best to show this? Given a table which has other tables and functions, no matter how deeply they're nested, we have something that will give us like the paths to the functions within that table hierarchy, and then the functions themselves, so that when we call them, we can get what the functions actually return. And I'm going to use that now. When we start instrumentation, we're going to go through that list of functions and instrument each function by producing a wrapper around the function and assigning it back to the into the table it started at. That way, whenever you call a function, it'll really start timing, then call the real function, and then stop timing, and then the stop timing will collect more information. So yeah, that's what instrumentation means, is arm the function, so to speak, with an extra thing before and after it, so that every time you call something, it'll start a stopwatch, do the thing, then stop the stopwatch, compare the two times, and record how long the function took to run. But I'm building up piece by piece, so I don't know if I'll get to the actual timing stuff. I at least want to make this unit test work where we define the global function foo, and then we call it, start instrumenting, call it 3 more times, stop instrumenting it, call it a 5th time, and then the instrumentation is just going to be a simple, like, print out the name of the function every time it's called. So we should just get 3 lines instead of 5, because we don't want it to happen before or after instrumentation. But during, like when the clock is running, so to speak, we do want it to capture those calls. So when it gets this global, it'll be different from that global, because this instrumentation would have replaced the real foo with a wrapper around foo that does the instrumentation. So the term is instrumentation because you can be doing all kinds of things. You could be instrumenting it to watch the stack or memory usage, or in my case, I'm mostly interested in the amount of time that is elapsed and then what other functions are called. So I could do things like record the fact that we're now in foo, so that if some other instrumented function gets called, that we know foo called that other function, and so we can develop a list of what are the functions that call foo, what are the functions that foo calls, and then how long each one took, and we can get a nice like report about like what are the critical paths in our code and that kind of thing. It's what Visual Studio Code does. I mean, what Visual Studio does for C and C++ if you use the performance profiler, and I really find that useful for C++. So I'm trying to kind of replicate that for Lua in a way that it's reusable. So you could take my Moon Clock library and use it for your Lua stuff if you had it. It's not going to be connected to my game at all. It's going to be a reusable component that I'll pull into my game to use to instrument it. So that's where I am. So the instrumentation code, it's looking at everything reachable from the global variables of Lua and going through each one of them. And I just want to record in a table somewhere actually, no, I don't want to record in a table. I don't need a table. I don't need to do this. I can just instrument it right now and do the other stuff later. So we're just going to get the number of functions. So const auto num functions is the raw length of the functions table. And then we're going to iterate through that. What type is that? Size T. Cool. All right. So we're adding 1 and then fetching it from -1. So, no, -2. Because at this point, this is what the Lua stack looks like. That's I plus 1, and then functions, and then the global table. And then get replaces the index with the entry. So that itself will be a table. And then the fn entry will be the function, right? So we're going to do Lua push string Lua fn. And then Lua raw get Lua -2. So again, I do these inline comments to just keep track of what's on the stack at what points. So the top of the stack now will be function, and then the table, and then the functions, and then the global variables. And then this gets replaced with that .fn. Then I want to do this wrapping. So we want to reassign it with the result of calling an instrumentation function generator, this is the tricky part. So we want to call a function that does the wrapping. So we'll make one. Let's make it here. Const auto instrumenter. Or we can call it something impressive like instrumentation factory. There we go. And we will say it has to be a Lua function. So Lua state Lua. And it should return a function. So it's going to be return 1. So we have to define a function. Oh, this is tricky. Maybe I'll do this with Lua load. Oh, maybe I should just do this in Lua. I don't know how in C to make a function. I guess that would be Lua load, right? Oh, this is tricky. If I make the instrumentation factory actually something in Lua, then we can call it. Let me do the. Let's assume we'll have an instrumentation factory at some point. I'm going to want to pass it along with its name, so we'll want the name in there. So Lua push string The name is available. Okay, we have to actually get it out. Name. Oh no, it was path, right? Yeah, path. Doing what in C? Doing this in C. So this is a Lua function, so to speak. It's not technically correct, it's more pseudocode, but making a Lua function that returns another function which uses the argument from the outer function, basically a closure. I don't know how to do that in C. So what I'm going to do is actually code that in Lua and then do a Lua load up here. And cross my fingers. Okay, so this will be, hold on, this with path in front. So that's 2, that's 3, and that's 4, and that's 5. And then raw get, but not 2, and instead it'll be 3, right? Yeah, 3. So now the top of the stack is that replaced with its Lua functions dot path. And then we're gonna just I'm gonna want to call the instrumenter. Let's put the instrumenter at the bottom of the stack in place of the globals. So let's pretend that we made it up here and we put it instead of the G. So so this G is instrumentation factory. Okay, so if the instrumentation factory is at -5, I want to call it and then pass it the function and the path. So I need to put it in position 3. So push value Lua -5. This is where Lua stack manipulation is really tricky. If that's now a copy of instrumentation factory's reference, and that's 2, 3, 4, 5, and 6. So the function protocol is function first, then the arguments. So I need to put the function in position 3. So that's Lua insert Lua -3, I think. Lua insert. Moves the top element into the given valid index, shifting up everything. Okay, so that would basically move that around so that these two move up front, which is what I want. And then that's -3. So 1, 2, and then that's 3, 4, 5. So when I call it, it'll be Lua call Lua and the number of arguments, which is 2, number of expected results, which is 1. So then I'll get one result on the top, which is instrumented. The instrumented function, so the wrapper that's generated, and then the function entry, the functions table, the instrumented factory, and then I'm going to want to take that and put it back into the table, right? Oh, I was going to have a table key in this table. I didn't. Instead, I had the path. Yeah. So let's assume that it's there. Well, I can't just assume it's there. Shoot. What am I going to do here? I guess I have to unit test that first. Well, let me write what it should be. So I want to have like get the parent or the table that the function is in, and then all this stuff. Instrumented function, all this stuff. And then its key value. So they need to flip this, right? So Lua insert -2. So flip the top two. So that is 1. And this is 2. And then, oh, wait. I messed that up. Shoot. That should have been there, right? Hold on. There would be a raw get, but where is which entry? Yeah, from 3. Okay. No, yeah, 3. That's table. But this is all wrong. That goes there. And then insert it to flip the 2. That goes there. The rest of it's the same, right? Okay. Then I got to actually do a raw actually not raw set. Do I do raw set? Yeah, because I was assuming it's only going to be used for tables right now. So I'm setting it back into that table. With the name. Oh, I need the name too. Shoot. This is really hard. I have to get the length of the path, and the last thing in the path is the name I got to put here. This is really tough. Okay, where is the path? I already popped it. Where did it go? Oh, I used it in that call. I guess I could look it up again. Or I guess I can push it on the stack again. Yeah, let's push it onto the stack again. So Lua push value -1, so just to get another copy of it, right? And so I have another copy of it. And these are all shifted. 4, 5, 6. Yeah, something like that in C. But the problem is it has to capture it has to capture the generated function has to capture the argument, the outside argument like that. See how that works? The fn is passed in, and then we're returning a new closure, really. So I don't know how to make a closure in C. A Lua closure in C is what I want to be able to make. I don't know how to do that. There's probably a way to do it, I just don't know. Because if we get the path, we get a copy of it, and then, so the numbers change here. The 5, what was 5 is now 6. Because this path has a copy. Oh, this is messy. Okay, let me do this a different way. Let's push the function first. Before but let's do that. And which one is it? It is 5. Right, so we get that exactly. And then I want the path. So that's -2. So let me replace this. So what was at 2 is now also at 1. 2, 3. What? Right. 4, 5, 6, 7. It's getting crazy. And then the function. So the function is where? It's at 4. -1 is now a copy of the function. Actually, I should have just looked it up there. Yeah. Yeah. One returns a struct of the captured data. Another function accepts the struct and additional parameters. I'm too tired to figure that out. Let me put it in my notes to read later. My voice is starting to go too. I'll give you a point for the idea. I'll look at that later. I have just enough brain power right now. Actually, it's past 3. I should probably call it here, take a break, and then get back at this. And I need to reorder the way I'm doing things. Like, I don't need the function until there, so I should probably get it and then push it here rather than doing push value. So this is correct so far, but then I need to take that and move it down here, and so these numbers all change. So what I'm trying to do is get the instrumentation factory, then get the path, then get the function call. Then with the result, which is the instrumented function, take that, get the end of the path and the table it's in, and put it there. And then we're done. Except for I need to solve this problem Nui's trying to help me out, where I need to get a function onto the Lua stack which does this, which returns another function which is wrapping the function to be instrumented. So the only way I know how to do that right now is to actually code that in Lua and do a Lua load here, which is fine. It's just at runtime it'll parse this instrumentation thing. It should work. Once I get that done, the stop instrumentation, this should be stop instrumentation. Stop instrumentation should basically unwrap everything. I should, in addition to putting instrumentation in place, we should also keep track of like which functions we instrumented and where, and then we should basically loop through again and unroll it. So it would be, we would keep original handle of the function somewhere, like in a table, and then put it back where it needs to go, and basically discard the instrumentation to unwrap everything. So I think to do that right, I need a Lua registry entry. So that's more work and more copying from somewhere else, and I don't have time for that right now. I gotta go. I'll finish this either later today or tomorrow. But once I get this done, then I can decide to actually pick what I want to do for instrumentation. So what I was going for today was the instrumentation would just print out the name of the function every time the function is called, and then we would verify that this works. But the real objective is, instead of just printing out the name of the function, we would remember that, hey, this function was called at this time, and since it's the same moon clock instance, we kind of also know what all other functions are still in the process of being called. So we have a whole like call stack, so to speak, of instrumented functions. We could take advantage of that. So we could record what functions call what other functions, what functions, or how long each function took, and then like if like foo calls A, B, and C, and we know how long it took to run A, B, and C, then we can take the sum of that and then the total time it took to run foo, subtract the two, and now we know how much time foo alone takes versus what A, B, and C each took. So we can sort of collect that stuff. Okay, let me grab that. This is in C, but I needed to end up making a Lua function. This will work in C, but not in Lua though. Mockup, yeah. So it's mockup code. When I refresh, renew my brain power, I'll look at that, and then that'll probably help me. So thank you again, Nui. I'll give you another point. So that's what I'm aiming for. That the instrumentation will actually track stuff, and then once we can introduce the performance counter to record the start time, the end time, and then just collect metrics on everything, and then we can just choose what we want to have show up in the report. So you want to do that using the Lua API, exactly. Yeah. Exactamundo. All right, I'm done for the day. Let me go raid someone. I'm just looking at my following list. See who we got going today. Oh, Tim was in here earlier, and I kind of said that we would raid him. I was helping him out the other day with, he's trying to write his own WebSocket code, which is near and dear to my heart because I did the same thing. And he's trying to write his own WebSocket code to connect his game engine to Discord. Alphabet soup. It looks like code to me. It's just not formatted. I just run it through the formatter, no problem. No, but that's what you don't have to apologize, Nui. The pseudocode alone will probably help me out. Hey there, Cthulhu. Sorry, Cthulhu, but we gotta go. I gotta go pick up the kids from school. So I'm gonna raid Tim. We'll finish the Lua instrumentation stuff tomorrow. So yeah, Tim's trying to connect his game engine to Discord through WebSockets. So that's kind of cool, I think. Let's go check him out. And then I gotta run. So thank you all for watching. I'll be back tomorrow to finish this work, okay? Bye.